Welcome, everyone. How's everyone doing? Let's go. Let's get some noise going in here. Woo! So those of you watching at home, we want to welcome you to a stream. Those of you watching right here, I want you guys to know that we are now streaming live to the SOLIDWORKS YouTube channel. So everyone here, no doubt you guys have taken part in some wonderful year-end festivities, right? You've taken part in multiple technical sessions. You've undoubtedly met multiple new industry contacts. We are live streaming here to the SOLIDWORKS YouTube channel to give everyone a little bit of a taste of what these events are like. So to give this event a name, this is the Western Michigan Lakeshore SOLIDWORKS User Group Summit. This is the year-end summit that's been going on for several years now. We figured, namely, I definitely figured, after having come to this event for the first time last year, that we needed to bring it to a wider audience here, namely all of you around the globe who are tuning in. So my name is Sean O'Neill. This is the final episode of the year of SOLIDWORKS Live on the road to 3D Experience World coming up in February in Houston, Texas. How many of you are thinking about going here in the audience, thinking about going to 3D Experience World or have already booked your tickets? Wow, so you guys can't get enough, right? Already so many amazing tech sessions that you guys have taken part in. Of course, you've heard about 3D Experience World throughout the year through some guest presenters, and we're not going to stop there. You can see to my left here, we have some guest panelists to talk about what it's been like on the road to World. Surely this morning, what we're doing here today, as well as what you'll be taking part in, both here in terms of future sessions that you'll be taking part in this afternoon, but also for those of you watching at home, some special tech sessions that we will beam you into right after this initial welcome session. But once again, this segment right here is about the road to World. Where have we been since the last World? How do we get here, and what's going on here today? But without further ado, let's do some brief introductions here, if we could.
Yeah. So good morning, everybody. My name is Jesse Rita. I'm the group leader for the West Michigan Lakeshore SWUG team.
My name is Matthew Clegg. I have the pleasure of working with the community team at SOLIDWORKS for the Champions, Influencer, and Sponsorship programs.
You already heard from me once today for those here in the room, but my name's Dan Wagner. For everybody online, I manage the user group network here at SOLIDWORKS. And I get to work with these two day in, day out on all community programs around the world, which is a lot of fun.
I'm Isabel Donaco. I'm also part of the user advocacy team with Dan and Matt. I help support SWUGin, the Champions program, Influencers program, and Sponsorship program.
So Jesse, if we could, as we pass the mic back, let's start with you. I mentioned this is a huge event. There are hundreds of people. I kind of see this, for those of you watching at home, almost as like a microcosm of a 3D Experience World, right? We talk about the networking, tons of SOLIDWORKS design sessions, other sessions as well, industry sessions. But when did this event start? How many years has it been going on? What was the sort of impetus behind it? All that sort of background info.
Yeah, sure. So our team has been in existence for about 10 years now. We kind of started as an internal user group, so relatively to inside of a company. That slowly grew as we expanded in the area, and this is our 4th year doing a summit. Each year tends to be a little bit more refined, a little bit better content. So I think we're doing pretty good at this point.
Yeah, and then I guess one of my colleagues here, if you guys could just talk about some of your impressions, as you've attended this event over the years.
Yeah, for sure. So Matt and I have had the pleasure of working with Jesse, Andrew, all the other leaders here for several years now, and our first visits out here to West Michigan were pretty, it was like almost like a culture shock. It was like there's hundreds of people here in West Michigan that get together to talk about SOLIDWORKS, learn new things, network with each other. And it's awesome for those watching online. Here in the room, there's several companies represented that have like multiple people from every company. So it's awesome to see that those companies see the value in sending their people to hang out with us for a day and learn tips and tricks.
Speaking of new faces this year, super proud to see all of the work all of our educators are doing locally and regionally. We have about 20-some students from Van Buren Tech here in the house. Woo! Big shout out to Mr. Josh Bridges. Joe and I had the pleasure of speaking to his classes yesterday about all things SOLIDWORKS, career manufacturing, you name it. So the evolution over the years, seeing us branch out into different forms of our community, be it at the early education stage, all the way through retirees. Big hats off to Jesse and the team for expanding our reach year over year.
I'd just like to say that the community is really what it boils down to, and that's why we exist and how this even exists. Without you, without your willingness to come, without that, there's no point in this. So thank you for all that.
Can I ask a question based on that? Because I remember, several years ago, I used to hear about, the SOLIDWORKS community, and I used to think, what is that? Like, how did you guys even figure out how to get to an event like this? Of course, yeah, right. It's like some people are chuckling. It's fortunate, of course, that many of you, I assume, and I know just through talking to you here today, that you are local enough to be able to travel to the event. But there are many others who travel from far away, many states away, right? So what do we mean when we talk about the SOLIDWORKS community? Because right here on the stage, we're representing different areas of it, right? We have the SOLIDWORKS User Group Network, the SOLIDWORKS Champions Program. So let's talk a little bit about how we can, maybe how you got involved and how others can get involved today.
Yeah. What it boils down to is a willingness and a desire to do it, to share that knowledge. And I think in the community, there's already an ingrained, call it a baseline, where that is just the norm. We are all here. We all regularly share information. That's kind of a core concept to engineering. But behind the SOLIDWORKS, I can't think of another software, another program, another thing we use that has anything close to this in any capacity like this. So, I mean, it's an absolute core tenet to the product. It's in how we use it. It's absolutely key to all of that.
After you.
Oh, if you insist.
You tried to pass the mic and pass yourself. That's insane.
We like to antagonize each other occasionally, but 3 decades of legacy that all of us have built together over multiple generations of designers, engineers, and that's what we get to enjoy. The programs that we've created, many of whom on this stage have taken part in those creations of community programs. We have the exciting job of building those together, and we talked about the Champions program. Sean O'Neill started that community 5 years ago, and I have the pleasure of leading that now. Several SOLIDWORKS champions in the room I see as well. Just a quick blurb about that program. We're 400 of the most passionate expert users out of 8 million around the world who go above and beyond in sharing our SOLIDWORKS passion expertise. And that includes the next generation of users here from Van Buren Tech and more to come. So it's a beautiful thing to be a part of. 30 years of relentless work and investment, and now we get to enjoy it. I'm extremely proud of it.
Yeah, it's a great point, man. I'm glad actually you're bringing up the next generation here too, because I think all of us, you could look around and think like, what has the SOLIDWORKS community given me? Like, what have I been able to learn from others and learn about job openings or learn about new parts of the software, and how have I used that to advance my career? So I think some of us who have been around for 10 or maybe 20 years kind of have a responsibility now to keep it going and bring up the next generation and make sure that they get the same benefits that we have for the first 30 years of SOLIDWORKS. So maybe, Sean, can I ask a question also? Is that all right in this panel?
No. No, I'm kidding.
Well, we have Isabel here representing the next generation, right, of some earlier career folks. Isabel, what was your perception walking in here today and seeing this is like the largest SWGN event, user group event that you've been involved with so far in person? What were your thoughts?
Even just coming into this role is like fairly new to the team. I know I've been here for like a year and a half, and it has been such a beautiful portrayal of like love and support, and I love to see it. So coming to these events is always just such a great experience because everyone's so friendly, so kind, so happy to help. And it's like that at every SWGN event, even in the Champions program, like everyone just loves to help and be there for you. And the support is so noticeable. It's honestly like a culture shock. You don't see this in other programs. And then when you come here, it is very specific to SOLIDWORKS, and it really is beautiful.
Yeah, I think Joe said it this morning, actually. Like, this is one of the places where it's okay to eavesdrop and listen in on conversations and, to your point, try to help someone else out. And John Sweeney, when he did his survey this morning, Sean, one thing he pointed out in the survey, there's a lot of new people here. How many first-timers here in the room at this event today?
There's a majority.
That's
yeah.
awesome. That is
crazy.
really awesome. Yeah, so that's great.
This is also one of the few places you can be in a room and not have to explain yourself, as opposed to Thanksgiving dinner. There's only so much you can talk about SOLIDWORKS API before people just stop eating and leave. That is not the case here. So let's not forget how special this is.
Very true. Very true. So, yeah, a lot there. But I mean, I can give out a web address or whatever. But if you just Google the SOLIDWORKS User Group Network, swuggen.org, you can get there. There are virtual events, there are in-person events, there are hybrid events. So really, any sort of way that you can and you'd like to connect, you really can. And SOLIDWORKS Champions Program, all the same. You can just Google the SOLIDWORKS Champions Program and get there. But I want to get back to our digital audience here. I don't want to neglect you guys, right? Of course, we have a lot of ways to stay engaged throughout the year on the road to world, as we're going to discuss a bit more here. But just take a look at this right now. So we're right now in that sort of welcome section, the road to world, what to know, where to go on our way to world, how to enrich yourselves, take part in the community a bit more, as everyone here has been saying. But we also have some tech sessions. Once again, we're giving you a little bit of the flavor of 3D Experience World here at this amazing event held by the Western Michigan Lakeshore SOLIDWORKS User Group. Man, every time I say it, I'm so proud of myself to get through that exact
We just call it Weimel Slug.
Oh, okay. But no, I mean, amazing event. So we have 2 tech sessions. We'll be simulcasting. I'll be serving as moderator in those. We'll be going over to a different room. Of course, everyone here has a whole slate of tech sessions, just like a 3D Experience World that you would to be able to get to. And then in the middle, we will also have a very fun activity, sort of interstitial activity, which will be right here on this stage, where we will take part in a fantasy draft for some of our favorite tech sessions as we transition from our first tech session here on site to our next one. But I did want to bring up, because many of us, hopefully a lot of you are subscribed to the SOLIDWORKS YouTube channel, but many of us, of course, watching digitally or watching through the YouTube. Some of us are probably on LinkedIn, of course, but many of us are watching through YouTube. So I want to kind of chart the road to world. And I think a lot of you in person, if you're not familiar with some of this content, we talked about learning and enriching ourselves throughout the year. I think this will prove helpful. But once again, I want to take a trip down memory lane. So Dan, you mentioned John Sweeney. He gave a great keynote on some R&D topics earlier today. My team and I, throughout the year, I work personally on product introduction content. Those of you who watch SOLIDWORKS YouTube materials, you probably have seen me before just kind of working on these sorts of things. But we most recently, just a couple months ago, released SOLIDWORKS 2026, the sort of first general availability release. And we also did what I believe was about an hour-and-a-half deep dive into SOLIDWORKS 2026. So, at the end of the year, it's a great time to be able to go back and see what you missed, right? Especially as a lot of you are, I'm sure, you might be a year behind on yearly upgrades. This is a great chance to go in and see conversationally the experts that put together these demos, what did they see out of the new features and what might you be able to reap? So definitely recommend going and looking for the SOLIDWORKS 2026 What's New episode in SOLIDWORKS YouTube. But we've also had some other user group events, right, Dan? So we can talk about this. This is Slug Me X. What is Slug Me? What happened here?
So I talked about this in our tech session earlier, that every year we do a kind of a larger event called Slug Me. It's the SOLIDWORKS largest user group meeting ever. We like our acronyms around here. That's something just to kind of get comfortable with. And we typically, as a group, will design something kind of crazy and then try to physically build it in our lab to share with the world, like that whole process. This year, we designed an actual dinosaur, fictional. We made it up. It's not a real one, but it's fictional. And if you know Jason Poole, he works here at SOLIDWORKS. At Jason's house in upstate New York, we physically built this thing. He did about 90% of it, and everybody else pitched in afterwards. It's like Disney quality craftsmanship. It's made CNC cut foam, hand sculpting. We shout out to Go Engineer here in the house. Someone from GoE's here somewhere. And there's Darren. Thanks, Darren. Shout out to GoE. They printed the head for us. This giant, it was like 50 pounds alone, just the head. And this thing's like 6.5 feet tall. And if you're going to 3D Experience World, you'll see it in person. And it is really seriously a work of art. It's pretty awesome.
I think one of my favorite aspects watching this stream, and this is available for replay, is it almost felt like, and I like to have this stuff on in the background, just because it just feels like a nice companion activity, nice little shadow activity while you're doing some work. But it almost felt like a cooking show, but for engineering, which I thought was really neat. So it wasn't just about 3D CAD, which a lot of things are, and that's great, but you could see some of the formulation of the dinosaur, some of the making of the props, some of the more behind the scenes stuff, and we got into some pretty tactile elements of just general making.
Yeah, and you get to go back to YouTube and rewatch all of it. In fact, if everybody here in the room could do me a huge favor and watch that stream like 2 or 3 times, I'm trying to pump the views a little bit before the end of the year here. So solidworks.com/slugmeatx. You can check that out.
So we have, once again, everyone here this afternoon, you know very well through your agendas that you have a large amount of different sessions to choose from in the ensuing hours. Once again, everyone that's watching at home, thank you so much for tuning in. You also have 2 great tech sessions coming up right after this talk. But this particular segment was called the Road to World. So I want to talk a little bit about 3D Experience World here, if we could. So once again, as you see here, 3D Experience World, it is in Houston, Texas this year. It's the first week of February. We're right at that point in time where you can still buy tickets, you can still book your travel. We have, I believe, over 260 sessions available on site over the course of largely around 3 days from Monday, Tuesday, Wednesday. We have activities on the preceding weekend you can take part in. It's one of the best for any SOLIDWORKS design user out there, anyone who's interested in simulation, really any design engineering. It's one of the best conferences. Thousands of people fly in from all different parts of the world. But yeah, let's talk about that just from your various different sort of learned perspectives here. Jesse, how about you? I mean, I want to hear directly from you because you are a SOLIDWORKS user today, right? You're a user group leader. So, you know, what appeals to you most about 3D Experience World?
It's kind of crazy, but at this point, it's kind of the social aspect for me.
Yeah.
It's this collection, this community of people, and the knowledge and just the good well wishes that we share at this point. You know, they all come to support me, and I hope to support them. And it is truly a community of people, and seeing them once a year at this big conference is always my favorite part of it. The other side of that is the content itself. Like, I'm a SOLIDWORKS expert, I'm a SOLIDWORKS champion. I'm at the high end of the curve, and every single session I go to, I still learn something new. And that's the thing about the software, is it's always evolving, always changing and growing. If you don't stay ahead of it, you're getting behind, you're getting slower, other people will beat you. So keep that going.
I think just to interject as we're passing the microphone down, I mean, that's one of the, I think, biggest misconceptions about a conference like this is that, you know, everything's online, right? Everything is online. But I think I speak probably for everyone in this room in that, especially when you speak about the networking aspects, it just isn't the same. Like, it is not the same in terms of bumping into people and having a shared experience and being able to correlate and then take that relationship kind of beyond an event like this or a conference like 3D Experience World. So you kind of need to get in person for those sorts of things. We have meetups that are like strategically planned events where you're able to meet others on a designated topic. We have, I think, like 40 or 50 of those throughout 3 days. So yeah, those are all really great points.
And I want to say, when it comes to the community and the network around it, it's not really wasted time. It's you know, yes, we're being social, but the social is around this community and around the content that we all share. You know, I always love to grill the minds of the other people I'm dealing with. What do you design? What's the product you build? Because all of them are cool. They all have something unique that you can take away and learn from. And that's the really cool part, is seeing what people do with the software, seeing what they, you know, hear the excitement in their voice as they tell you about what they do.
Matt, I mean, you've been on both sides, right? In terms of world, right? You've been on like 3 sides. I know there are a lot of partners in the audience today. You've used SOLIDWORKS in industry, of course, and now you're leading the Champions program. You're working with all these crazy design content creators out there on YouTube and other areas. But yeah, so given that, what are your perspectives just on world in general?
The community that we've built is so deeply creative, and my understanding of how deep that well is, it's deeper every year. It's incredible. We talked about SlugMeX with the dinosaur. There are not many people, groups of friends that you can just get together and do that stuff with. Like, it's just a fun thing you pull out of your mind, you do. We have tools to do it, but we spend a lot of time focusing on software, on code behind it, very technical stuff. But I think it's important for us to take a step back sometimes and acknowledge how deeply creative we are as a community and what we can accomplish together in the world of design of any dimension, pun intended. And this event, World is the ultimate expression of that. There's no other way to experience the scope and scale of what we do year-round. It's a year-round project that we work on. Meetings usually every week, to discuss how we can keep evolving this event and bring people like influencers and students and educators and benefit people and inspire them. And we carry that momentum year round.
Awesome. Yeah, how about you guys? I mean, again, everyone has different perspectives here. Just as once again, we're probably about 5 minutes away from transitioning over to the next set for you watching at home, the first set of technical sessions. But just as we close off here to maybe further inspire you to check out 3D Experience World.
Yeah, and Matt, I think you brought up a great point that you might not always be aware of how everybody else uses the software and everybody else's perspectives. And I, prior to this role, like Matt, spent some time at a reseller and got to experience 3D Experience World, SolidWorks World as a reseller employee, which was great because you are kind of on the front lines of the technical support aspect and going to technical sessions and that sort of thing. But if you're a designer, and I would hear this in tech support all the time, I think it's easy to kind of end up in a bubble of where you model sheet metal parts. So that's really all you ever see, and that's what you spend your time on. But going to events like this here today, even if you're here virtually, or going to 3D Experience World, it's a chance for you to talk to someone else that uses the software in a different way, that models something completely different from you. And it's just such an awesome learning opportunity. Sean, I'm going to ask one more question here on the end, if that's all right.
Yes.
Because I think the four of us here have a lot to gain from the younger generation that's represented well here in the room. But that's something for us at 3D Experience World we're trying to figure out, and even at events like this here today, is how do we get the next generation to come, and how do we make it interesting and exciting? Isabel, maybe I could ask you for 3D Experience World. You went last year for your first time. Was there anything that stood out to you that, like, hey, I think maybe the average engineer, average younger, newer engineer isn't aware of? Like, was there anything that stood out to you, or any other tips you'd have for a new person?
Honestly, the excitement at this event is contagious. That is something that I didn't realize. You think conference, and you think sitting a long time and having to pay attention and all that. And it seems like a lot of work, but it's really not work at this event. It is actually really, truly enjoyable to be there. Like, the excitement really was contagious. Like, I could not stop smiling while I was there, having a good time. The people are so worth it. And I don't think you get the same sense of community anywhere else that you do get at SolidWorks. I just think the younger generation, especially my generation, doesn't understand the community aspect as much, because I think a lot of it may have gotten stripped away with all of this online work and online schooling, and trying to get us back into that feeling of just contagious excitement and support. I think it's really important for my generation to value again, because you don't realize what you've missed until you went there and you felt it. Like, it's been so long since I've felt that feeling, and I'm very excited to go to World for my second time, next month. It'll be a ton of fun, and I'm ready to feel that level of energy again.
You just made everybody up here nervous. We said next month, because we're like, oh my gosh, you're right. That's just like, it's basically barely a month away, right? Yeah. Yeah. That was a great answer, though, Isabel. Thanks.
No, it was. Yeah, it's part of, I think, hearing from each of the four of you, once again, is that you all have different perspectives for various different reasons, right? And those aren't necessarily things that I would have currently thought of. So that's awesome. So we are right around 1:30 Eastern. So we're getting ready here to move on to our first tech session of the live stream, but we're many sessions in here in person. So yeah, once again, 3dexperienceworld.com if you're in person, or if you are watching online, check it out. We just announced, by the way, Jensen Huang, NVIDIA CEO, is one of the speakers at 3D Experience World this year. That's not something I necessarily expected to be able to say today, but that's pretty insane. Obviously on the forefront of AI, as well as a lot of other things. By the way, thank you. Thank you all for first of all of you for coming here. Everyone's sitting up here for educating, inspiring all of us. And I will see all of you who are watching here right now online in just a moment, as I'm going to moderate the forthcoming tech session. If you have any questions, ask them in YouTube live chat. I have my phone on me, and I will navigate that whole deal. But yeah, stay tuned. We'll be right back. All right, welcome back. Welcome back to SOLIDWORKS Live. Welcome to all of you for taking part in this special session. I'm here with Paul DeWys. Paul, how's it going, man?
Good. Yeah.
Thanks.
Guys.
Yeah, so you are all over the world and you are here in person, both at the same time. But I wanted to reiterate, I will be your moderator, so I'll be working for you during this segment. And for those of you watching at home, I will be checking the live chat on YouTube. So if you're watching on LinkedIn, maybe pop over to YouTube. And if you have any questions during the middle of the segment, just ask away. I'll be taking a look and I'll raise my hand for you and we'll ask Paul. But very excited about this. Thank you so much, Paul.
All right, everybody. Thanks for coming out. My name is Paul DeWys. I'm a sales engineer at Forerunner 3D Printing. Like our moderator said, this isn't really a lecture. This is more of a conversation. So don't wait till the end for questions. If you have any questions at all, doesn't matter how big or small of a question it is, just raise your hand. I'd rather answer it right then and there when we're on the slide. So yeah, looking forward to going through all this stuff with you guys. So let's get into it. All right, so kind of getting our start in 3DP. So it actually starts quite a bit before. So back in 2009, I was at Fair State University and started doing contract CAD design while I was in college using CATIA V5. And then pretty quickly, when I graduated, I graduated in 2010, and let's just say there weren't a lot of manufacturing engineering jobs in 2010. So I moved back into mom's basement and just started seeing if I could find more customers. And so pretty quickly, I realized that, you know, CATIA was fine and dandy, but the world ran on SolidWorks. And so we got a seat of SolidWorks and started, you know, using that and kind of built the engineering side of our business from there. So from 2009 to 2016, built our engineering business. That business still exists and runs today. That's our DeWys engineering business unit. But in 2016, we had started, you know, maybe a year or two before that, we started to use 3D printing quite a bit in our product development work. And then in 2016, the company that I was working with, the gentleman who owned it was retiring. He didn't really have a plan for his business. So I actually bought the assets of his 3D printing business and formed our Forerunner 3D printing business unit. And so since 2016, we have just been very slowly growing the additive side of our business to where we are today. And so, you know, I started out literally sitting in lectures just like you guys are here today, you know, over a decade ago. And so I try to inject these with not only, you know, let's talk about SolidWorks, but let's also talk about design for additive manufacturing. Because, you know, when I first started in this, it was just 3D printing. There really wasn't additive manufacturing outside of some very niche applications, but that has really changed. You know, over the years that I've been in the industry, basically what's happened is a lot of patents have expired, and there's been this Cambrian explosion of startups, both big startups like HP, not really a startup, but they have a startup 3D printing business inside of them, all the way to companies like Formlabs, where it was literally some guys from MIT who were like, let's build a resin printer. And, you know, they built this very large company off of that. So, you know, in the time I've been in the industry, I've watched all these new entrants come in, and they have enabled true additive manufacturing. And so just like if you were designing for CNC machining, sheet metal, castings, injection mold, there are ways you design a part, okay? If you're designing for an injection molding process, you know, you better make sure you have consistent wall thicknesses. You better know how it's going to get out of the mold. It's going to need draft. How are we going to get the steel out of these undercuts? You know, versus if you're designing the same part, but you're going to machine it, there's a whole nother set of problems there. And so what I try to teach is additive is just like those. Yes, it's very forgiving. You can get away with a lot of stuff. But if you're going into production using additive, there are still rules and methods that you should use to make the, you know, a cost-effective, good end-use additive part. And so that is what I'm going to focus on here today. I'm going to try and give you some SolidWorks tools, and I'm going to try and give you some design for additive knowledge that you can kind of leverage. All right. So, you know, I just got done saying, well, there are rules for 3D printing, but a common thing I hear is, but I thought 3D printing gave you unlimited design freedom. It does, but if you optimize your 3D printing, if you optimize your part for the 3D printing process, you can achieve added benefits like isotropically strong parts. So, if you think about a traditional part coming off a 3D printer, it is strong in X, it is strong in Y, it is the weakest in the Z direction, the layer and the direction in which you stack your layers. There are ways around that. Less post-processing time. The biggest hidden cost with 3D printed parts that no one really fully understands unless you've ever printed parts yourself, and then which case you really understand it, is what happens after you're done printing. You have all that support that has to come off. What happens to those support faces? Are we sanding them? Are we leaving them as is? Are there critical tolerances off of those faces? How you support your parts or how you design your parts to avoid support can massively save you costs. I'm working on a program right now for a large suppressor company, and they are having us basically design parts for cleaning suppressors. And the initial design that their engineers sent me, it was a beautiful part, but it was covered in support. And they're like, we got to get this down to $6 a piece. And I'm like, just in the amount of post-processing for someone to break all this support off, you're at a $10 part. I said, give me your SolidWorks files. Let me iterate your design. Took the design, iterated it, sent it back to him, said, this is the part we can do for $6. And literally it prints, you break it off the build platform, you drop it in a box. That's it. And that's how, through the power of just design, I was able to go from a $10 part to a $6 part. And then added functionality and unique features in your part. There are really cool things that you can do with additive that you cannot do with any other 3D print or any other manufacturing technology cost effectively or at all in some instances. So, and then also lowering cost. I already kind of touched on that, but through good design, you can drive your cost down considerably when you're looking at production additive parts. So the following are examples of parts either designed specifically for the 3D printing process or that were redesigned for it. All right, so first thing I like to do is kind of level set and make sure that everyone understands what I'm going to be talking about here. So I've got some very nice animated videos I stole off of YouTube, and we're going to talk about 3 different printing technologies so that everyone's on the same page. So when I'm babbling about SLA machines or MJF machines, you're not like, I don't know what any of those things are. So the first thing we're going to talk about is an SLA machine. So an SLA machine is also sometimes known as a resin printer. Now, this is a traditional old school laser-based SLA machine where you have a laser up above your print bed. It's coming down, and wherever that laser, which is a UV laser, wherever it hits that resin, it hardens that resin in about, anywhere from 3,000ths to 10,000ths layer thickness, depending on the settings of your machine. Now, nowadays, a lot of people are familiar with like desktop DLP machines, desktop resin machines. So those work off of a DLP screen where they actually pull the part up out of the vat and they're just flashing an image of that slice of the part layer by layer. These really work the same way. This one uses a laser, a DLP machine uses a screen. This one, the part builds down into the tank. A DLP machine, the platform builds up out of a tank. But for our discussion today, resin DLP machines or resin SLA machines, all the same kind of rules really apply. Next up is FDM. Most people, when they think 3D printing, they think FDM. It's a CNC controlled hot glue gun. You have filament, in our case, usually ABS or nylon or PETG or something like that, but maybe PLA or even TPUs. You have a filament. You basically run it through a nozzle that's heated. That nozzle melts the filament and extrudes basically hot plastic layer by layer. In this case, the black represents the actual part, and the kind of ivory color, that is support. So just like I should have mentioned this, SLA machines, you have to support your part. If your part is just hanging out in space, it will build a blob of nothingness. You need to have a foundation underneath it. And so these machines print with support, both FDM and SLA. When you're done, part comes out of the chamber, break all the support off of it, you got your part. The last technology we're going to talk about is MJF. MJF is a powder bed machine. So this is a whole other type of 3D printer. Some people may be familiar with SLS 3D printers, where you use a laser to sinter powder. An MJF machine actually sinters based off of color. and heat gradient. So basically, you lay down a 0.003 of an inch thick layer of nylon powder, you spray a black, basically colorant onto it, and then you hit it with a high intensity IR lamp, and it selectively melts. The blackened areas absorb that IR energy. The white areas around it, they reflect it. And it's just like at the end of the day, in the dead of summer, you walk outside and your car's in the parking lot, and there's a black car and a white car. And after baking in the sun all day, the black car is 10 degrees warmer when you get in than the white car, because the white reflects the sun's energy, the black absorbs it. The MJF machine works the same way. We literally selectively melt by color. SLS technology, the powder handling system works the exact same way. The difference is, instead of doing it by color, they literally have a laser beam, and they're in there melting that powder with a laser beam layer after layer. But basically, you get a part out either way. And the cool thing about both these technologies is there's no support. Because you're laying down a full layer of powder every single time you do a layer, the part becomes self-supporting. So the sample parts kit that everyone should have, in here, these card holders, these are MJF. These came off of an MJF machine, and that's how those gears are able to move on there. Those gears were literally printed in place on these cards, and they were just floating in powder, and we literally use a bead blaster to strip that powder off, and you get a part that comes out with motion on it. That is an MJF part for, as we're kind of talking through this. All right, moving right along. So first thing we're going to talk about is specifically around SLA, and this can also be somewhat applied to FDM as well. Designing support-free parts. This is the single biggest thing you can do to reduce the cost of your 3D printed parts coming from a company like ours. Anytime a person has to touch that part, that's going to be the most expensive piece of that part for the most part. Part. I said part too many times. Anyways, so the trick is, how do I design a part that doesn't need support? Well, you can harken back to what the Romans did. Think about arches. Think about self-supporting geometry. If you go and look at pictures, of old, churches in Europe and stuff like that, everything is an arch. Old bridges, they're all done with arches. Or they have angles that are at or above 45 degrees, because again, that is a self-supporting structure at a certain point, once you get past 45 degrees. So in the case of this part, this is we call it a blow vac block. And basically what it does is it blows powder coat off of one side of a part. It's actually a reel of stamped material. They put powder coat onto it. They don't bake it on yet. And then they blow the powder coat off the bottom side of the part, but they want to leave the powder on the top side of the part. And then they run it through an oven to basically cure the powder coat. So this basically strips uncured powder off the bottom side of the part. So there's a lot of vacuum and compressed air flowing through this block. And so the first one we did it with machining, and it was like 5 different pieces all assembled together with like gaskets and O-rings, and it was just really a pain to do. And so we said, hey, let's actually do this with an SLA printed part, because we could take and we could print it without any support on the inside, and then all that resin, that liquid resin that's left on the part afterwards, will literally just flow out through all these air channels. So what we did is we basically said, okay, we have this big air chamber in the center. I'm going to turn on my laser pointer here. So basically, this chamber here in the center, you can see it has an arch. That is where we blast compressed air in, and it comes out through all these holes in the top. All of that is self-supporting structure. And to either side, we have these kind of vaulted like ceiling chambers. We're drawing hard vacuum through there. So as we're blowing the powder off the bottom of the part, it's vacuuming into the sides of the blocks. And again, this block is solid. We couldn't get support out of there if we printed support in there. So this was a case where we had to be really sure, obviously when you go to your slicing software, it's going to say like, I need to put support in this area, but it's nice in SolidWorks without having to like save out an STL, open up your slicing software, import it, support it. Oh, it puts support in there. Okay, back to SolidWorks. It's better if you can see that in SolidWorks. So one of the little tricks that you can use is in SolidWorks, there is a tool that's called Print 3D. This guy right here, I know it's probably hard for you guys to see with the resolution, but that says Print 3D. And Print 3D opens up a tool inside of SolidWorks that actually basically simulates whatever 3D printer you want. And when I say simulate, it's not like necessarily you see the printer like printing your part, but like it applies all the rules and shows you how big the print bed's going to be. So we go to Print 3D, and then you can pick from a huge list of printers that they have. Unfortunately, SolidWorks hasn't seemed to update this list in quite a while, so a lot of these are older printers. But you can also make a custom printer in there as well. Basically, give it the X, Y, and Z bounding box of your printer. You pick the bottom face, and then you actually get to see your part sitting in there. So let me switch back over and play this video. So this is a video of me actually using this command. So I went and I picked the command, and I picked my printer, which I picked a 3D Systems resin machine or SLA machine. And then I picked the bottom of my part, and it actually drops down to the build platform. So I can see, like, is my part going to fit on the printer that I want to use, which is handy, especially if you're like printing right at the maximum extents of what your printer, or if you're designing at the maximum extents of what your printer can handle. This is, again, a very simple way to quickly check, is everything going to fit without having to export or like draw a sketch in your assembly that represents your build platform. So, so that's kind of the first thing that you can do. But then there's another tab up here at the top with the red arrows at. It says Preview. So then if you switch over to the Preview tab, you can turn on Build Analysis tools. And so the first tool is going to show you areas that need support versus areas that don't. And the second tool is for layer height. So I'm going to play this video for you, and you'll actually see this. So the build analysis, I set it, green is good, doesn't need support. Red is bad, needs support. Now, there's a level of human intelligence that has to come into using these tools. The computer is going to guide you, but it's not going to be perfect. So in this case, you can see it's saying, hey, you need to support the tops of all these arches and everything. Well, I know I don't. But the computer is saying, well, technically it's 0 up there. It's going to be under that 45-degree rule. You have to support it. So there's a level of like, you got to be able to look at it and go, okay, I know what you think you're seeing, computer, but I'm going to use my human intuition and go, this is going to work. So that's something that you have to keep in mind. These tools are not infallible, so don't put all your faith in them. The other thing you can do is layer height. So here, this blue box, that blue dotted line box, you can actually turn on it will put basically a layer height representation on the sidewalls of your parts, and you can actually see like inside, like, hey, here's what your layering is going to look like. So I just set it to, I think this one was set to 5 or 10 thousandths. Might be this. I think it was 10 thousandths. I wanted them to be thicker. And so, if you're doing like a piece of industrial equipment like this, I don't really care what it looks like. I just need it to be strong and functional. So, but there's many times where maybe you're doing a, display, and it's going to be on a piece of trade show equipment, and the boss comes into your office and says, hey, we're taking this to Automator, we're taking this to IMTS. I don't want this thing to look like a piece of crap, okay? So like, you can print it, but like it needs to look really good. Well, what this can be really good at is if you have parts that have shallow angles to them, or if they have like a really swoopy organic surface that you're going to be printing, especially if you're printing on like an FDM machine, it can leave some really weird looking lines in your parts from just how those layers stack up in there. So I've used this before to kind of say, okay, I want to print my part in this orientation. What is this sidewall going to look like with all this geometry on there? And you kind of look at it and go, oh, that doesn't actually look so bad. Or like, oh, wow, like if I tip it 10 more degrees, suddenly that whole face is smooth. Or I stand it up and now those layer lines are so thin that you can't really see them. So this can be a tool that can be helpful more so from a cosmetic preview of what your part might look like than maybe so much a buildability, which would be more like what the red and green is showing you. Okay. So a bit more practical example of all of this. So we make a lot of hand applicators. Oh,
Hey, Paul. Hey, we got a question from the chat, and I think this actually relates to, and this is from Vincent O'Regan. So thank you, Vincent. This question, I think, relates to a bit of the presentation that you passed by a couple minutes ago. But Vincent asks, which machines in your mind are best suited to which materials?
Oh,
Is that-
that's a big question, Vincent. Which machines are suited to which materials? It is a never-ending Rubik's Cube that I play on a daily basis. I have tons of materials. I have a bunch of different machines, and it's an unanswerable question without knowing what you're trying to do. So, like when I'm talking to customers, they'll send me a part for quote, and a lot of times I'll look at it and they'll say, "Hey, Paul, quote me one of these, and I want it in ABS, and I want it black." And then I'll look at it and it'll be like, maybe I know the customer, maybe I don't. If I don't know what they do, the very first thing I'm going to say is, "Sweet, thank you for the information. What are you doing with this part?" And then they'll go, "Oh, it's a trade show model." And then I'll go, "Oh, okay, so let's run it on an SLA machine and let's crank the detail all the way up and let's make it look really good. And then let's prime it and paint it, or let's prime it and sand it and paint it. And it's going to look like an injection molded part." Or he might come back and say, "It's a mount for a camera inside of a piece of assembly equipment," in which case he doesn't care what it looks like, but it better be strong and it better not vibrate. So then I'm going to go, "Okay, let's run it on an HP MJF machine in nylon 12, and let's make sure that it's going to be really strong, but I'm not going to put any effort into post-processing to make it as cheap as possible on that side of things." So that's the best answer I can give you, is it changes job to job, part to part. Good question, though. Okay, so we make a lot of these hand applicators, and these hand applicators are used to apply double-sided sticky tape to all kinds of different things out in the world. You'd be amazed at the amount of things that are held together with double-sided sticky tape. I think Elon is holding tiles on the SpaceX rocket with double-sided tape. Like, I heard they were experimenting with that. Like when they were first, everyone was seeing all these tiles fall off. Like they were trying like glue and tape and rivets. And so anyways, crazy things are held on with tape. Our customer has a lot of different hand applicators, and they used to literally just make them out of a block of wood. And so a guy in their wood shop would sit there for like half a day with like a chisel, like literally hand carving like applicators. And that was great until their customer said, "Now I need 100 of them." And that guy in the wood shop's like, "I'm not making 100 of these." So they went to try and get them machined, and it was just expensive. They were going to machine it out of Delrin. They start with a big block of Delrin. They remove some chips from it. It's multiple setups in the CNC machine. It got prohibitively expensive. So they came to us and they said, "Hey, you guys do that 3D printing thing. I heard 3D printing's cheap, but we think you guys could do it." So we looked at it, and we did. We printed a very basic one, and they were like, "Yeah, that's a good start. Like, it's definitely cheaper than any other way we've been able to do it." But then they said, "Hey, what'd be really cool is when they basically take this roll of tape and this block and they lay this piece of tape down, then he reaches into his pocket, the operator does, and pulls out a little roller, and he goes along and he rolls all the air bubbles out of it. Is there a way that you can have the roller and the tape guide in one?" And we said, "Probably." So what we did is we took the applicator and we said, "Okay, we need to get a roller inside of this applicator." So that's the white piece that you can see in there. And there's actually, it's actually just a piece of saw cut, like literally UHMW, like buy a stick of it from McMaster car for a couple of bucks. And that's another thing I'll say. 3D printing is not the solution to all your problems. 3D printing is one more tool in your toolbox. I can't beat the price of a stick of UHMW from McMaster. Even with McMaster pricing, I can't beat it. So we use it where it makes sense. So we got our roller, and then we printed an applicator, and we kind of stood the thing up and printed it. And the issue with basically any kind of 3D printing, but especially FDM and SLA in some instances, if you try to print a round feature and you lay it down on the print bed, it's going to print oblong. It's going to print like an egg. It's just the nature of how those machines work. The bottom is hot, the top is cool, the bottom will settle as you're printing, the top will print more pointy, the bottom will sag. So if you're trying to get a really round feature, you really need to print it straight up in the Z. And that goes for any 3D printing technology. If you need it really round, point it straight up. Do not lay it down. But the problem there was we were like, okay, we got to print it straight up and down. We also can't have a bunch of support in it. So what we ended up realizing is if we just cut the tool in half and we laid it open, basically like 2 pieces of bread, and we printed it straight up like that, we would get no support inside of those roller pockets. They would be very nice and round. And then we would literally take and we could print it flat on the print bed. So you can see, that's what I'm kind of showing here. These are laying flat on the print bed. And the only place I had support was in the pocket for the head of the bolt and the pocket for the hex nut. And I don't care what the inside of those pockets look like, doesn't matter. So literally, we would print these things, break them off the build platform, flip them over, use like a little butter knife, pop those chunks of support out of there, done. That's done. And we literally we were able to take and drive our price down to the point where our customer was like, 3D printing really is cheap, which is, again, it's not, but that's just the way it is. Like, it's all in the eye of the beholder. It was way cheaper than what they were paying to machine them. So again, the point I'm trying to make here is like, get creative with your features. Like, think about breaking things apart. Think about how can I set something directly on the build platform? How can I not use support? That is the biggest thing that will save you cost and aggravation, especially after the part comes off. Yes, sir.
What do you do after you remove the support? What do you do with the support?
Throw it away. Yeah, yep. So it's waste material. There are companies out there that offer like regrinders so that you can extrude it back into filament again. Our issue is it's so time consuming and you don't ever get the resin to be as good again. For us, we just throw it away. Some materials like nylons we can recycle. ABS, sometimes we can get that to recycle. PLA, not really, but it's a bioplastic anyway. So it just gets thrown away. Does that make sense?
Yeah.
Okay.
When Dad uses the standard 3D printer, he has one of the things that shreds it again.
Yep.
It's standard, you can just always get melted.
Yep. So good question. All right. So that is kind of the long story short on these hand applicators. One last thing. So on these applicators, there's a ramp basically that goes up and down to where that roller is at. When we were printing it straight up and down, we were getting really bad stair stepping in that ramp. Again, by splitting it and laying it down on its sides, you get nice, smooth, continuous machine motion. So that ramp is perfectly smooth going up and down. So again, just hearkening back to, orient your parts for what you need them to do, and you can get some really cool results. All right, kind of circling back into SolidWorks again. So this is a one I see quite a bit. It doesn't matter any 3D printing technology. It doesn't matter what machine. This applies to any 3D printing technology. STL files, not too big, not too small. So I will never forget when I first got into this business, I was working with one of our machine build customers, and lovely guy, a little on the older side, and he was so excited about 3D printing. He was going to use his first 3D printed part on a machine he was designing. So he said, hey, what file format do you want? I said, I want it in STL. He's like, all right, no problem. So he sends me an email with a FTP attachment. I'm like, that's interesting. He sent it via an FTP. It's got to only be a couple megabytes. He sent me a 1 gigabyte STL file. And I was like, what has gone wrong here? And so I downloaded it, and I very slowly opened it over lunch. And when I came back, it was so tightly meshed. And I'm like racking my head. I'm like, how could this happen? And so I call him up and I go, hey man, why is this STL a gig? And he goes, oh, I need it to be really smooth. And I'm like, okay, but why is it a gig? He goes, well, I was looking at the export settings in SolidWorks, and I saw that you could turn the accuracy up and it made it smoother. And so I just turned it all the way up, and I saved out a 1 gigabyte STL file, so it'll be really smooth. And I'm like, all right, well, the first thing I'm going to do is I'm going to click a button called decimate, and I'm going to reduce this thing by like 99%. And I guarantee you it will be as smooth as if I printed the one you just sent me. And some people have the misconception that if I save out a really big STL file, it's going to make a really, really smooth part. That has absolutely nothing to do with it. Now, you can save out. I've seen it the other way too. I've seen it where people are like, I don't want to use the FTP. I want to send this part through email. Let me slide it all the way down. And then your round hole looks like a stop sign. Okay. So this goes both ways. But a good mesh is what I'm going to make regardless. Now, if you send me a gigabyte file, I can make a good mesh from that. If you send me a stop sign, I'm going to call you and say, hey man, send me a step file. I'll make the STL for you. But if you're making STLs yourself, these are our best practice right here. If you go into STL, so if you go File, Save As, pick the STL, and there's a button that says Option right there on the Save menu. If you hit Option, it will take you to this screen. Our general rule of thumb, tolerance of 3 thousandths for your deviation, angle at 5 thousandths. And you will get a sphere that basically looks like this right here. So yeah, so that's just a quick little aside. STL quality does not equal part quality. All right, glue joint design. So this is another thing over the years that I've seen, people kind of struggle with, and it can be challenging, but there's some simple things you can do that really make it not too bad. So glue joints. If you're working on a desktop printer or you're working on a Fortis 900 that's got 32 by 24 by 36 inch build volume. I've split plenty of parts that fit on a Fortis machine, and I still had to split them. Car trim pieces is notorious. You think about a piece of trim on a car, it's not fitting on a 32-inch platform. So when you split them, there's a couple things to think about. First things first, do not just cut the part cleanly in half, because then my shop guys are sitting there, and one of them's holding the glue with an activator, and the other's holding the part, and they put glue on it, and they slam it together, and then they shift it and shift it and shift it, and they go, it looks good, and then they hit it with the activator, and then they flip it over, and it's crooked. So you can't just do butt joints. It's not going to work. You got to have a locating feature, some kind of locating feature. So a locating feature can be as simple as a puzzle piece. You look at these joints up here at the top, you think about a puzzle self-locating, okay? You want to do the same kind of feature in a glue joint that you design. So the other thing that people sometimes don't consider is think about the forces that your glue joint is going to see. So if you have a part, and let's say, imagine a 2x4, okay? And if you're putting a force directly down in the middle of the 2x4, if you split it through the top of the 2x4, or you can split it through the side of the 2x4, the side is going to be a stronger glue joint if you're pushing down on the top, versus if you're pushing on the side, you'd want to split it from the top. Think about the direction your forces are going through, and make sure that your glue joint or your puzzle piece is counteracting the forces that your joint is going to see. So one of the things you can do is well, what if I have forces coming from all directions? Okay, we'll do a 3D glue joint. So you can see here in this part, what we've done is we put a kind of a puzzle piece through the part right there. But then if you look at it from this side, it also looks like this. So I've got it basically puzzle pieced from 2 different directions. And now I have a 100% self-locating glue joint, okay? There's no way my shop guys can put it together wrong, because you can only really put it together one way. They'll still do it, but I'm giving them the best shot I can. I'm trying. So anyways, the best commands in SolidWorks for this is surface sweep. Yes.
Another question from online here, from the chat. So, and it kind of relates to this. Can you explain your thoughts on tolerances for printing? Dealing with shrinkage and possible cooling distortion.
Oh man, yeah. This is a huge part of my job. I had an automotive company send me a print on Monday, and it is for a piece that is going to get fiberglassed into the hood of some kind of high performance vehicle. And it's 7 inches in outside diameter. And they said, yeah, we need that outside diameter to be plus or minus 1,000th. And I said, there's no way. And they said, but there has to be a way. I said, there's no way. There's no way. You cannot, I don't care. I've built, in my entire 3D printing career, I've built one part that I was able to hold plus or minus 1,000th on. It was the size of my thumbnail, okay? And I worked on it every day for a week of doing test build after test build after test build. And I dialed that file in so I could hit plus or minus 1,000th. And then a week later, they changed the CAD, and I had to start all over again. Like, if you're trying to hold that tight of a tolerance, it just is not feasible. So on that part, that specific part, I said if it's a 7-inch diameter circle, I can hold plus or minus 35 thousandths. So plus or minus 0.035 thousandths of an inch on the outside diameter. And they said, okay, well, what if we don't care about the outside diameter? We care about this inside diameter that's about 4 inches across. And we need that to be plus or minus 10. I said, still can't do it. Still can't do it. Plus or minus 10, I can be the size of my thumb, basically. I can do plus or minus 10. So what you learn, and there's no book, there's no school, there's no nothing. You learn this from doing. You learn this from printing a lot of parts and measuring them and learning, because every part is different, every build is different, every machine is different. So unfortunately, I can't give you like a hard and fast, like these are the rules, but I can say design through experiment. That's how you get to those tight tolerances.
Especially in the 3D printing community, the word tolerance and the word clearance often get transposed. Can you hit the difference of those two things?
Yeah, so clearance, clearance in my interpretation is two things need to move past each other. And maybe they're pretty far apart, or maybe they're really close to each other, but at the end of the day, they should be moving freely past each other. That should be clearance, okay? Tolerance is, I have two parts that maybe need to be a press fit, so I want them to press together. There's a tolerance that I would associate with a press fit. Or, I need these two things to fit together, and, if it prints a little big or it prints a little small, I want to make sure I know what window it's going to print in so that whatever's around it interacts with it correctly. So like tolerance is more of a measurement. Clearance, also a measurement, but almost more of a feel or fit. So that makes sense? Okay. Glue joints. All right. Got me going on a tangent there. At the end, there's going to be, you all have my business card. And for the people online, at the end, my email is going to be on the screen. I will email you this presentation. So if I gloss over something for the sake of time, please hit me up. I'm happy to send you the full PowerPoint. Anyways, there's some more stuff on here about glue joints. I'm going to skip it for the sake of time. One thing I will say, though, we've tested more glues than I can even name. The best glue we've ever found for general purpose gluing of 3D printed parts is Loctite HY4070. That is by far the best glue we've ever used. It sticks to everything 3D printed and a lot of things that aren't. Okay, how to design 3D printable threads. This is like my stand on the hill and die type of feature right here. So you can print threads successfully in a 3D printed part. Now, with FDM or with SLA or DLP, it's a lot more challenging to get really good threads, especially the smaller you get, the more challenging it becomes. But powder bed, MJF, and SLS, you should print threads anywhere, anytime, all the time. It's just the way to do it. The way to do threads inside of SolidWorks, and I'm just going to talk over this video here, is by combining a couple of things in SolidWorks. So first thing is the hole wizard command. So you go into hole wizard and you go into your tapped hole command and you pick the size of threaded hole that you want. So in this case, I think it's going to be 1/4 20. 10, I think it's number 10 maybe. Anyways, doesn't really matter. So I already have a sketch on there with points in the corner. So I'm going in there, I'm dropping my hole onto my sketch point, and then I'm going in there and I am just basically selecting, yep, this is the size I want. Definitely don't remove the threads. That's what I'm like frantically signaling at right there. Do not remove the threaded area from the screw or from the hole. Some people do that, then this will not work. So it drops in a nice cosmetic, like visual threaded hole. It'll look great on prints, but if you try printing it, it's just going to print a smooth hole. So if you hit the drop down underneath your hole command, there is, I'm skipping ahead, chamfer. Next thing you do is chamfer. Think about designing threads for printing just like you would machine them. First you drill the hole, then you chamfer the hole, then you tap you tap the hole. So I put my chamfer in there. Now I'm in the thread command, and you can literally search for the thread command in SolidWorks. I'm picking the outside diameter of my tapped hole, or hole that's going to be tapped. I'm picking the top surface where I want the thread to begin. And then I'm going down and I'm picking the thread size. I really wish SolidWorks would just make it so that whatever the hole size is already called out at, it would default to it. They don't do that. And guess what? You feel real dumb when you print a part and you go to put a 1/4-20 in it and you're like, these threads don't work, and you realize you never picked the actual thread size that you wanted. So we have our thread size in there. Another thing, make sure you offset the first thread above the top of your part. And if it's a through hole, offset the bottom through the bottom of your part. Because again, you feel real dumb when you print your part and you go to thread it in, you realize the thread stops midway through the chamfer and you can't thread anything in. Done it a bunch of times. Feel really dumb every time. So again, there is your nice threaded hole. Now, again, another enhancement I've asked SolidWorks for repeatedly, and they seem to be doing other things. You have to do this to every hole. Like, there's no way to just like pick a bunch of holes and just have this, populate. The way around that is to use a sketch driven pattern. So that's why I already had my points called out on there. So I'm doing a sketch driven pattern to actually pattern all my tapped holes. Now, granted, they all have to be the same size. They all have to be the same everything, really. And it only works if they're in the same plane, unfortunately. But if you've got a ton of holes to do on a part, it's way faster to do it with this than to do each hole individually. And it keeps your tree from being like 3 miles long. So, yes.
A part like this, I know in some applications it might not be the case. Wouldn't it be more equitable? And maybe this doesn't work on 3 different parts, but just to literally tap it out with an actual tap?
Absolutely. But this in this context, this would be a production part. So there could be thousands. So the reason I promote it, and we'll get to it right now, it's free. It's not free from the time commitment, but it doesn't cost you anything to print this into the part. So with CNC machining, if you machine a block and you just drill a hole in it, that costs $1. And then if you say, now I want you to tap that hole, well, now they got to load a tap in the machine, they got to program it, and they got to run it, and they got toolware. So now that part costs $2. Okay, there's an incremental cost for adding features. With 3D printing, I don't care if it's a smooth hole, I don't care if it's a clearance hole, I don't care if it's a tapped hole. Doesn't add any cost. So you get the tap for free. So that's why. Yes. So it's not as strong as like tool steel or something like that, but the part you see over there on the right-hand side, so that is a eye bolt that we downloaded from McMaster-Carr because they have threads and everything, which is handy. And then we drew a little test block, and that's a 1/2-inch thread. I think it's a 1/2-inch coarse thread. We put it on our pull tester, and we took it up to 900 pounds in tension, and we broke the pull tester. We rebuilt it, and we got it up to 1,000 pounds before it failed. And where it failed was at the first thread of the first turn of the thread. Basically, where the cross-sectional area of that eye bolt was the strongest or the weakest, it cracked right there. And we literally took a punch and spun the broken piece of the thread back out of the hole, checked it with a thread gauge. The threads were fine. It didn't elongate the threads or anything. It was a material failure, not a thread failure. Now, you want to put a metal eye bolt in there? Oh, yeah. You could rip it out, but I wouldn't want to be standing next to it when it comes out because it's going to go frickin' flying. And we've done that all the way down to on MJF powder bed machines, the smallest we can print a thread is a 632. And we literally bought 632 eye bolts and threaded them in there, and the eye bolts were failing when we were pulling on them. The threads were not. So it's never going to be as strong as a metal part, but it is totally serviceable in high strength applications. I would not like hang human life off of it, but if you're bolting something together and putting it in a machine, we have machine builders do it all the time. Yes, sir.
Do you typically put solid, or do you have like structures inside of it?
Depends. So if it's like an FDM part, we might use an infill just to save material and save cost if we can get away with it. With the powder bed machines, sometimes we'll print it solid. Sometimes we'll honeycomb it to take mass out of the parts. Again, it depends on the part and depends what the customer is doing with the part. So stronger parts, print solid. Weaker parts, we'd print hollow or we print with infill. Okay. So I'm going to breeze through this one for the sake of time. So heat sets, these are basically metal inserts that you can melt into your part. We do a lot of heat sets. So now, why would I use a heat set instead of just printing the thread in? So what will happen is a plastic thread will wear out. So if you have a piece that's getting put together and taken apart every shift or every other shift or something like that, eventually a metal fastener on a plastic thread will wear the thread out. So if it's something that sees a lot of assembly and disassembly, we recommend a heat set insert, because now it's at least a brass thread that you're threading into. From a strength perspective, we have done a bunch of research, and we've got it all published on our website, where we actually did pull out testing to qualify like what kind of loads could you expect a 1/4-20 heat set insert to hold when it's melted into a part. And it's hundreds of pounds. It's decent. But you're really not doing it for strength. You're doing it for wear. That's the biggest one. Or if you're worried about whoever's going to be putting it together not being careful, because again, it's a plastic thread. So if they, get a 1/4-20 bolt and they put an Allen key on it, and then they put a pipe on that, and then they put it in a vise, and they lean off the side of the table as they're tightening it, they're going to pull that thread out. It's a plastic thread. So if you're worried about assembly, maybe pulling the threads, again, that would be an argument for a heat set. If you get this PowerPoint from me, this link is clickable. This blue link is clickable. It will take you right to our website, and all of our data is published. So I see some of you taking pictures. All these rules right here are driven off of a table on our website. So we'll literally tell you, buy this McMaster insert, design your hole this way, and here is the performance data you can expect from that fastener. So if you want this, either email me, you all got my card, or come up to me afterwards and we can exchange info. But either way, you're going to email me, and I'm going to send this to you. It's very helpful. Let's see. Oh, one thing I will say, I see people get this wrong a lot. If you're doing a blind hole, and you can actually see right here, if you're doing a blind hole, do not stop the hole at the bottom of your insert, because when you melt it in, all that melted plastic has to go somewhere, and it's going to go down and it's going to go up. And so what will happen is it will bounce off the bottom and mushroom back up into your threads, and you'll go to thread your fastener in and go, why is my fastener a 1/4 inch off the bottom? Well, it's hitting melted plastic in there. So what you want to do is, if it's not a blind hole, or if it is a blind hole, you want to basically add double depth to your hole to give that plastic somewhere to go, or make it a through hole, and then you can at least, run the fastener all the way through, or get to the back side of it with a drill bit if you have to clean that plastic out of there for some reason. All right, another SolidWorks tool, texturing. So this is something that has absolutely exploded in the last couple of years. So the cool thing about 3D printing, and I've said it once and I'm going to say it a couple more times, is there's no added cost for complexity. Complexity is free. And so what you can do is you can use the 3D texture tool in SolidWorks to actually apply textures to your part, and it will print directly on there. And now, if you were machining this part, that means you're going to be in there with a 30 thou cutter trying to cut this texture out on the surface of your part. It's going to cost a fortune. If you're injection molding, you can absolutely do texture, but you're going to bring someone in to actually either acid texture your mold, or you're going to sit there with a 30 thou tool and you're actually going to etch the texture into your tool, which is a one-time cost, but it's still a cost. With printing, there is no cost to adding texture. The cost is your time sitting in front of SolidWorks doing it. And so you might be thinking, why would I put texture on something? So sometimes it's purely cosmetic. Sometimes you're working on a part and it's maybe it's a prototype for a product, and the product's going to have texture on it. You want your prototype to have texture on it, so you can do that. Maybe you're trying to hide flaws in the surface. So that's another big one is, I was talking earlier about having layer lines on your parts. You can, by applying textures, a lot of times you can hide really bad layer linering. I don't even know what I'm trying to say. Layer lines inside your part. They do this a lot. If you go when you get in your cars, when you're going home, get in your car, look at the dash in your car. It's got a fake leather texture on it. Okay. Well, it looks nice, but what you don't realize is they're hiding flaws in that injection molded part because of that texture. There's knit lines, there's seam lines, there's probably deformation from ejector pins and stuff on the back side of that big, huge dash part. And by texturing your dash, it hides all of that. So you can do the same thing in 3D printed parts. You can hide a lot of crap with a texture. Now, texturing can get challenging on SLA and FDM machines. The Bamboo machines have opened my eyes to what is possible with texturing. In this presentation, I used to say, don't texture on an FDM, it won't work. Well, it will work now. Bamboo machines will do texture, and it's kind of incredible. But SLA, and especially the powder bed machines, MJF and SLS, that is where you can really start to go nuts with your textures, because in those powder bed machines, you don't have to worry about support, okay? The workflow in SolidWorks is pretty simple. It's pretty simple. It's simple to do. It's hard to always get exactly what you want. So it comes pre-populated with a bunch of textures built into a library. And if you go out and search like 3D printing textures, there's a ton more of those floating around out on the internet that you can find, more than just what comes with SolidWorks. So I'm applying it to a face, and then you go to your appearance command tool, and you can start to wrap the texture around the rest of your face. Where it struggles is 90-degree corners. It will not basically wrap the texture around the 90-degree corner. It will just kind of slam two textures together. So 90-degree corners are kind of tough. The more organic your part is, the better the texturing does. It just kind of swoops around everything instead of like hitting those hard corners. So then you go into the 3D texture command. You literally can search for it, 3D texture. I'm not actually sure where it's at in the menus these days, but 3D texture will get you there. And at that point, I strongly recommend go on YouTube and find a tutorial that walks you through this step by step, because you'll never remember what I'm about to tell you up here. But basically, you enable your textures, you set your height, you set your quality, and then it will apply the texture in real time to your part. And so there you go. You can see the part just basically turn black because I turned the quality up quite a bit to get the texture to be nice and sharp. So now I'm applying the texture. The texture is applied to the part. And hopefully here in a second, I'm going to green check it. It looks like I'm still kind of optimizing the texture. So yeah, so now I'm going to go green check it. And so now I have a textured part, and you can't really see a lot. It just looks like kind of like a black cube, because there's so much, basically it's showing all of the triangle delineating lines. So you turn that off, and now you can actually get you can actually see what the heck you're looking at. There's your textured part. Now, do not do this until the end of your design. Like, do not, first off, if you do this in the middle of your design, you straight up, you can edit the part after this, but you really can't, okay? Not the way you're gonna want to. This is like the last thing that you do in your tree, so that when you go to make an edit, you can just, you know, roll your bar up one notch, it goes away, and then you can edit your part and go back and fix it. Because if you change any face IDs, it will break this. It just blows up. It doesn't do a good job with changes. So do it at the very last thing. But play with it. It's a really cool tool. For a long time, I was like, this is neat. I don't know what I would use it for, but in the last couple of years, I've used this on some really big projects, and customers have been absolutely thrilled with the results. So don't sleep on the texture tool. And again, I have this full tutorial. I have a full page on our website just about how to use this tool. So again, if you email me, I can get you a literal like instruction page that'll walk you through this click by click. Mesh editing. So remember, I just told you like, hey, you know, leave your STL stuff to the very end, because up until 2022, you could not edit any kind of STL file in SolidWorks. Well, 2022, they started adding functionality where you could actually import an STL file and start to edit it. And so over the years, this functionality has come along to the point where now you can go and get an STL file, you can bring it into SolidWorks, you can run feature recognition on it, and if it's a really simple part, it will feature recognize. Like Hawkridge has a really flashy video out there that I saw on YouTube of them like bringing in this cool shaft with all these splines, and it's an STL and like 3 button clicks, and it's like, and now it's a SolidWorks part that you can use move face and do all this stuff on. yeah, it worked on that one part. I don't ever really get to work that well. So what I'm showing you here is more of a real world example of actually editing the mesh, not trying to feature recognize it, but like actually working with the mesh. And so what they've done is they've added, let me turn my laser pointer back on. They have added a mesh modeling tab up here at the top. So if you go up to your tabs, right click and go to tabs, and it'll give you the whole list of them. There's one called mesh modeling. And what they've done is they've basically taken a bunch of tools that were sort of used for mesh modeling scattered all over SOLIDWORKS, and they condensed it into a single tab for us. And so what happens is you bring in, you basically open an STL file in SOLIDWORKS, and when you do that, you go to your mesh modeling tab and you click on convert to mesh body. And what that'll do is it will basically take that STL and sort of half-ass convert it to a body in SOLIDWORKS. And then you can start doing things like put a sketch on it. You can draw holes like you just saw me doing. You can extrude cut those holes through your part. You can do chamfers. You can do radiuses. You can basically do subtractive stuff. If you want to do an additive, like you want to actually draw something off of it, then it starts to get weird because now you're mixing, you're doing more of a hybrid model where it's like, yeah, this piece is an STL, and then I'm like extruding this box over the side. And if you look in your tree, it's like you're going to have a graphics body, and then you're going to have like a real SOLIDWORKS body in there as well. And they're just kind of grown off of each other. Now, if you're going to be, 3D printing or something like that, you just go file, save as STL. It basically busts the whole thing out as an STL, and you can go throw it on your printer. But if you're like going to go to the machine shop and you're like, hey, here's my step file, they're going to go open it and be like, what the heck is going on? Half of your model is like, surfaces and clean mechanical data, and half of your model is like 10,000 triangles. So like, this is very much a workflow for printing, not so much a workflow for like going to the machine shop. Quite honestly, like if you do need to like actually reverse engineer something, like reverse engineer an STL that you could take to like a CNC machine or something like that, that's where in Premium there is it's a point cloud editing tool that also deals with STLs and SOLIDWORKS. Not designed to part. Scan to 3D, thank you. Scan to 3D is question? 10 more minutes, perfect. All right, scan to 3D, free plug for SOLIDWORKS Premium. Pay those subscription fees, totally worth it. So anyways, text and logo design, it really sucks on FDM. It sucks less on SLA. It's awesome on MJF and SLS. You can do logos, you can do text. If you want to know more about this, send me an email. I can send you all the stuff. Sketch Picture Tool. This is one I wanted to get to because this is one of the most slept on features in SOLIDWORKS. If you, for example, are trying to get a company logo or anything like that into your design, and you do not just want to open it up, make a sketch picture, and then spend the rest of the afternoon clicking with splines, tracing things out, you can use the sketch picture command. I don't have time to go through it step by step, but again, I have all this published on our website. And if you go on YouTube and you just type in SOLIDWORKS Sketch Picture Tool, there's tons of guys on there that would show you exactly how to use it. It works pretty good on simple logos, simple text. If you're getting into like a real logo or like anything really complex, it's better to use a piece of software called Inkscape. Inkscape is free. You can download it. There's tons of tutorials on it. If you go and you just type in like how to get DXF from Inkscape, there's a ton of great YouTube videos and it works really, really well. So like SOLIDWORKS Sketch Picture, works good for simple logos. Inkscape, you save out a DXF. That's how you do your more complex logos. Snap design. I guess any questions? Anything that anyone wants me to circle back and talk more about? You guys have been doing a good job of asking questions while I've been going, but anything else here before I just burn up the rest of this time? Anything from the chat? Okay, so I'm just going to run it right up to my time limit then. So snap features. This is one that, I mean, forever people have been using 3D printers to prototype. Okay, you got a big injection molded part, you got a bunch of snaps and screw bosses, and you got stuff that's getting assembled together. You design the whole thing, you print an SLA, you print an SLS part, You get it in, you snap the thing together, you put your screws in it, like, yep, everything looks good, and you throw it in the garbage and you go kick off the injection mold. That's fine and dandy. This is more of a discussion of snap features for a printed end use part, a printed production part, okay? So, you know, when you're using it for prototyping, those snaps basically have to go together once, twice, maybe 3 times. And if one of them breaks, you're like, well, it's just a prototype, I don't really care. But if you are printing a production part, you need those snaps to survive, and hopefully they can survive for quite a long time. So one of the things to keep in mind is if you're using, say, FDM or SLA, you have your layers. Your parts are strong in X and Y, they are weak in Z. So if all of your snaps are standing up off of your part in the Z direction, they are very weak because your snaps are built layer by layer by layer by layer. So you may get 1 or 2 snaps out of them, and then they are just going to snap off, and that's that. If you need your snaps to last, the better thing to do is to lay them down so that your layers are going out along your snap, and you can get a lot more life out of your snap features by doing it that way versus standing everything straight up in your machine. Now, again, with MJF and SLS, those rules go out the window because those technologies are what they call isotropic. The parts are the same, basically the same strength in all 3 directions. Z is a little weaker, but not by a lot. So if you do have a part with a ton of snap features on it and you do want them to last, SLS or MJF is a better way to get them printed versus FDM. But if you're using FDM or you're using SLA and you want to stick with those, lay your snaps down, don't stand them up. You know, all the classic injection mold snap designs that work in molding also work in 3D printing with the above caveats applied to them. So, you know, you've got cantilever snaps, L snaps, U snaps, all that stuff will work to varying degrees in printing. But again, with printing, you can break all the rules. You can design stuff that, and if you designed it and took it to an injection mold shop or an injection mold builder, they're going to look at you and go, you're out of your mind. This makes absolutely no sense. Well, again, for us, complexity is free. So this is a enclosure that we did for a customer. It basically adapts a power control board. It holds a power control board on the side that's facing up, and on the bottom, you would snap a Milwaukee or DeWalt battery onto it. And so what you're going to see here is I have the control board, and I'm fishing it through the top there, and I have these snaps around the outside edges. So out here at the 4 corners are these snaps, and you can sort of see cutaways of them right here. They're an L snap with like a top hat on it, basically. And so when I push it down, you can see those snaps are snapping over the PCB board as I snap everything together. And I've got some little locator towers in there as well to keep everything in position. So you can see those snaps are over top of it. So, okay, those are now holding my board down onto those locator pins. So now I believe the next thing here is I'm going to put the cover on it, maybe. Let's see. Nope, I'm going to bend these wires around. So there's pockets in this bottom side where these blade connectors, they sit down in these pockets. These are the blades that actually stick out. So when you put your battery pack on it, these are what actually get energized by your battery pack. So I'm kind of just wrapping these wires around into here, into those pockets. And once they're down in there, I have another cover, basically, that's going to snap over this side. And it basically just has 2 cantilever snaps standing up off the top of it. Nothing too crazy. They snap down into this pocket right here. So I'm going to grab the cover here a second. So you can just see cantilever snaps, nothing too crazy. Just push down, and it snaps everything into place. And so that's a pretty, you know, nothing too crazy on that one, but it was the perfect solution for holding those blades in position. So now, let's see, I'm going to flip it over, and I believe now I'm going to put the cover on the top side. So let's kind of skip ahead here a little bit. Okay, so here's the cover. So this particular customer, they wanted this to be a one-way snap. Once this thing's put together, they don't want the cover to come back off again. So they want to put it all together, snap it, and then send it out into the world, never to be opened back up again. So the reason that we have this top hat type design in here is this top hat actually catches both sides. It holds the board in and it holds the cover on top. And it's a one-way snap. So once you push that cover down on there, it forces those top hats in and they kind of cram the board and they pop back out and it locks that cover in place and you're not getting it back off again. I actually put little holes in there so I could get in there with a pen and open it back up and take it back apart. And when we went into production, we got rid of those holes. So again, this is just an example of like how crazy you can get with your snap design strategy, where you really couldn't economically do this with a molded part, but with printing, you know, you can get away with whatever you want. So, all right. So that is basically the end of my presentation, or my time anyways, not the end, but close enough. Grab your phones. There's my email address. If you're online, please screenshot the email address. If you want this PowerPoint, email me. Email me and I will get it for you. So thank you so much for your time, guys. I appreciate it.
Okay. All right, we are actually live. Welcome back. We are at a bit of an interstitial segment. Yeah, if you guys could stand clear of the camera here, that'd be awesome. Just because it's, we're basically right in that point of view right there. But yeah, how was the session that you guys attended? You guys have a good time? Yeah, we are almost ready to go to the next session, both online and in person. So I'm glad to hear that you guys learned a lot. Once again, thank you all for tuning in. Thank you all for coming. We still have a lot more to get to here, but as a bit of an interstitial activity, we want to at least get through one round of a fantasy draft for 3D Experience World. And I am so lucky to be joined by 3 individuals who are actually presenting at 3D Experience World. So if we could just have some introductions, just kind of going down the line here.
Sure. I'm Joe Lance. I'm the president of the Houston SOLIDWORKS user group. Been for a long time. Looking forward to this event.
Yeah.
Adam Ebernickel, the user group leader for the Western North Carolina Asheville SOLIDWORKS user group, as well as a Southeast committee rep for the SWOGN network. Been doing that for a while, presenting quite a while, and I'll give some shameless plugs for a couple of my presentations at World.
Martin Onimus with Napite Manufacturing, and I currently lead the Napite internal SWUG, the co-leader of the PDM SWUG, as well as the draft site SWUG.
Awesome. This is great. So what we have here is just a small segment of the selections, a portion rather of the 260 plus sessions that are available at 3D Experience World. If you go, once again, first week of February in Houston, Texas. And we have 3 different categories. So we have best practices and workflows. These are your lecture style sessions from different SOLIDWORKS employees, different partners, different industry users as well. We also have hands-on workshops where you get to sit down on the machine and actually go through the picks and clicks of so many different things. Be running simulations, meshing different files. It could be different SOLIDWORKS design level workflows. It could be almost anything. We I think have over 50 hands-on sessions scheduled, as well as meetup sessions where it's a focused activity, right, where you get to meet others in that specific interested discipline or area. So what we're using right here is called 3D Lean. It's part of a package called Lean Team Player. It's basically a virtual whiteboard. So I figured, hey, let's run a fantasy draft with some of our favorite sessions. And maybe we're a little bit biased, but that's okay. Who better to get it from the source, right, in terms of some sessions that you can take part in at 3D Experience World. So I've reordered our little order here. I'm going to go first since I have the board right in front of me here, and I am going to go with top 10 simulation mistakes to avoid, because I need to give simulation some love here. So this is an awesome segment, and one of the reasons why I selected it is because, well, first, it's really easy to understand exactly what I'm going to be getting into as part of the segment, but also because there's so many different SOLIDWORKS design segments. I know some of the sessions that you guys are getting into, so I wanted to make sure the simulation got some love here as we got into it. It's not just a design, not just a CAD conference. There's a lot of different topics that are portrayed. So if you wanted to select that session, you can't because I took it. I'm sorry. All right, so we're going snake draft style. Joe, you are next. What is your selection? What are you taking off the board for us here in our fantasy draft?
Well, I'm going to take off the board the Jazzy Trio.
That's off.
How to navigate your career.
Ah, Joe.
All right, so
Imagine
Joe.
that. Man, Joe, that's a good one.
Give us the what and why, Joe. Why did you select this as the second overall pick in our draft?
Well, I selected that because it's near and dear to my heart, and it's something that I definitely have a lot of experience with. We're looking at a century of history there, so I think I have pretty good input with that. So that was my choice.
Yeah, and this is this is not the first time that you have presented a rendition of this particular session, right?
This is the first time of the century. Talking about that, what we've done before as the Jazzy Trio was more of a tips and tricks.
Gotcha.
But we saw a need for people just want to know what the longevity is all about and how to get there, and we thought we were very instrumental in that.
So it says Jazzy Trio brings together more than 100 years of professional experience.
That is correct.
Can't always get that online.
No, can't get it online. That's
Nope,
correct.
not at all. So I think that's a great selection. All right, so let's continue on to the third overall pick with Adam. Adam, from the bank of available sessions, hands-on meetups, best practices. What are we going with next?
Okay, so let's see what we got here. I think the one I'm going to select, again, shameless plug I mentioned, right? So we're going to go with shameless plug, and I'm going to do mastering metadata.
Good choice.
It's off the board.
Right
There you
there it
go.
is. Mastering metadata is one that I had done for Iron Swug this year. And it's a pretty good one. We're going to talk about metadata, what is metadata, why it's important, how it can benefit you in your everyday work practice, and maybe even how to simplify things and make it more efficient when you're trying to build out your data sets and stuff for your drawings and things of that nature.
Now, Marty, as you contemplate your selection here among the available, I just want to reiterate the purpose of the exercise. It's a bit of, once again, an interstitial kind of on our way to our next tech session. But if you have registered for 3D Experience World, that's awesome. But if you're like me, you probably have not filled out your agenda yet. That's probably, you mentioned this earlier, just try to have some level of preparedness before you get to the conference in Houston. One of the best ways to do that is just take some tips on what are some sessions that seem interesting to you, seem fulfilling to you, seem like things you can take back to your workplace. And so we're hoping that we can impart some tips there or encourage you to register and take the trip to Houston. So having bided you a bit more time, Marty, what is your selection?
We will go with the shameless plug of
One's off the board. PDM Administrators Meetup. So yeah, it's not just a design conference, huh?
again, near and dear, as co-leader with Tom and Craig. This is a great event. It's been packed every year. We have lots of admins from all around the country come. We have great discussion. It's just kind of an open walk through the challenges that we have. And in fact, last year we were pulling chairs from a room next to us. So it was, it's always a good time, always fun to hang out with all the people. So.
Awesome. All right, so let's try this round. We're right at 3 o'clock. So let's try to do rapid fire. One more here for each of us. I'm going to go with Tyndall's tips or top 30 tips from the train. Anyone who's on LinkedIn that follows SOLIDWORKS topics, you know Leonard Tyndall. He's always bringing it in terms of 3D Experience World. He's flying from overseas. You know he's always prepared. If you're a SOLIDWORKS user, you have to go to this session. That's my pitch. All right, Joe, you are up.
Oh, my second would be, I think I'm going to go with Sketch for Success.
There we go.
Sketching tips.
Awesome. Can't go wrong with sketching. And then we have Adam, your second pick.
All right, let's see here. So the second pick's going to be a meetup session for me.
Building out a well-rounded agenda
Is it
here.
on here? Is it on here? Yes. Gears, grease, and SolidWorks. So if you're a grease head, a gear junkie, you like to make a lot of cool stuff in your spare time that's not necessarily for work, right, guys? Yeah, not necessarily for work. We're going to call these government jobs that we like to do at the house for our cars and motorcycles. Come check this meetup out. We're going to be there talking about all these cool things we do.
Part of a mega meetup. This is going to be a packed room. So yeah, if you want to meet people, the best way to do that is in person. We have a lot of topics here, but that's certainly one of the great ones there. And then Marty, with the final pick of our abbreviated fantasy drafts, what do you got?
I think I'm going to pick the large performance for power users. I'm pretty sure that's a Lynn.
There we go.
And yeah, Lynn always is great. In my opinion, he is probably one of the world leaders on large assembly. And he's presented all around the world, for that matter, on large assembly. So yeah, I'm excited. Anytime I can see one of his presentations or any of these two, anybody's presentation, I'm excited. But I'm a nerd for SolidWorks. So, but it's all good. It's all good stuff. And I'm very excited to see it.
That title, Large Assembly Wizard, job title. Like not many people have that in the world, right?
Right.
Yeah, Large Assembly Wizard. I believe that's like his legitimate job title at Trimax Solutions. So Lynn is awesome. But once again, you heard it from these guys here. You heard it from me. Heard it from hopefully many others throughout the day today. As we head into our second tech session of the live stream here as we continue this summit, please go to 3dexperienceworld.com for more information. You can view all the sessions there. You don't have to register. You just view all the sessions. And hey, we hope to see you there. But until then, we have our next tech session coming up. I'll be moderating that one. and we'll see you shortly. Thanks, guys.
Thank you.
Thank you. farther, and if I click on the part, now I can see the planes and the origin of that particular part as well too. And again, I don't have to, if I want to try to find that front plane that everything's centered on, I don't have to go looking for it. It's right there, right? Don't have to expand anything out, don't have to scroll. In fact, a lot of times I'm kind of getting to the point where I'll just shrink this down, and every once in a while I need something over there, but I'd rather just focus on this right here. Now, it is in the upper left-hand corner of the screen, and if you want to, if you go into your features here, and we'll type in breadcrumbs up here, you can show it next to your mouse pointer as well too. So if you find that you're using it all the time and you're tired of going up to that upper left-hand corner, turn it on, it appears right next to your mouse. That way you'd only have to move your mouse a little bit to get it there. Now, some of the functionality that you have in here is, you know, like maybe I need to open up the subassembly, and sure, I can right-click on a part, and then I have to come up here, and then I have to hit this little down arrow, and then I can kind of see the structure. I've never been a big fan of that. Here, when I click it, I can see that subassembly, right-click on it, and everything is available. I can edit features, I can switch directions. So if you put a mate on and it inadvertently puts it in upside down, well, you just right-click, you click the part, click the mate, right-click on it, make it inverted, and you're done.
I don't have to find it. I don't have to edit it. I don't have to do anything for it at that time. Again, I can come through and open it right here. I don't have to go through some weird little drop-down menu. It's all just there. So probably one of the biggest tools that I did not like them when they first came out. I thought it cluttered up my screen. I'm like, this is ridiculous. I actually turned them off. And through doing large assemblies and helping companies out, a lot of times I go into companies and I'm like, yeah, like we've got functionality that does that. You need to get out of the Stone Age. And then I started realizing I was doing the same thing. I was turning off new functionality, not even giving it a try. Turned around, started to use it. I literally cannot live without it. I had to jump on 2007 a couple of years ago. They didn't have it back then, and I was lost. I'm like, oh my God, I gotta go through all this stuff, and it was crazy. So just know that they're there. Pretty nice. Yes, sir.
Maybe you're gonna get to it, but what about keeping the breadcrumbs in the upper left-hand corner and using the D key? Because that's how the pros do it.
Oh yeah, you could hit the D key, but that's delicious. No, that was DeWys. Yeah, never mind. I have some stuff, but we're being recorded today, so you and I will talk afterwards, Mr. Scotty. All right. So yeah, the D key will snap any of those icons, whether it's your OK or your close out a sketch or anything like that. So that's some fancy button pushing in case you like working like stuff is 1995. All right, so let's see, what else are we doing here? No, that's good. Close that down. Let's jump back in here. Mating on the fly. This is probably one of the other things that I have found to be quite beneficial with SOLIDWORks. I put a lot of stuff together, and you can get into a big groove where you just start clicking through. So what do I mean by mating on the fly? Well, it means I don't get into I don't go to the mate toolbar very often or the mate function very often anymore. So let me go ahead and grab this assembly. Let's grab the assembly. And, Legos will make more sense later as we get in here deeper. And yeah, so I got my parts here. Well, I can come up here, and I'll tell you right now, the only time I come into this mate tool anymore is honestly for the mechanical mates, screw mates, cam mates, stuff like that. Any advanced mates that I use regularly, profile, symmetric, width, limit mates, all that stuff is available in what I'm going to show you here. But the main thing here is to understand what's going on in the background. So for the first part, if you pick two flat faces and you're going to mate stuff together, by default, SOLIDWORks is going to pick the coincident mate. It's going to make those two faces coincident to each other. I'll ask you, if I pick two cylindrical pieces and try to mate them together, what do you think the default mate's going to be on that? Thanks. Concentric, right? And if I pick something round and something flat? All right, so you've kind of learned what the major default mates are in SOLIDWORks. And it doesn't sound like a lot, coincident, concentric, and stuff like that. But if you really look at it, those are the mates we use the most. I mean, they're going to make up 95 to 98% of all the mates in an assembly. And it's going to be sprinkled in with some distance mates or width mates and stuff like that. So I can use that to my benefit. In fact, here, if I go ahead and just grab two faces here that I want to mate together, if I let go of the control key, so I do have to use a control key here, unlike the mate tool. But if I zoom in, we will get this little mate icon here, all right? Now, what I found is if you look closely, there's one of them has a little dash box around it, and that's the default mate that SOLIDWORks is going to use there. And if you know that that default mate is the one that you're going to like, you can hit the enter key, and it will go ahead and add that mate in for you. Now, that doesn't seem to be like too awful cool, and if I hit the enter key, but really when you start getting things together here, you can actually start putting mates in a fairly quick fashion. Ooh, yeah, that wasn't nearly as neat as I thought it was going to be. Maybe had too much crumble cookie there. There we go. So I can quickly start getting everything that I need to be in the right place, and it's just a matter of going through and picking the faces. Now, one of the things you might notice is I'm not really letting that menu come up. I understand what mates I'm going to use. I understand what SOLIDWORks is going to offer me, and I am picking faces to be conducive to that. I'm picking flat faces. I'm picking cylindrical items. One thing I did do that I customized, it's not in SOLIDWORks. You actually have to go through Windows. I have a Logitech mouse, and I have to go into their little app thing, and then what I told them was, one of these little buttons that everybody has on their mouse, but a lot of people don't use. I turned one of them into an enter button. And in my case, it's my thumb that can click it. So instead of having it hit the enter key, I just twitch my thumb after I pick 2 faces. A lot of times I can do it quick enough that other people, I mean, you don't ever really see that menu pop up. It just kind of happens. And if you got people that are new to SolidWorks, it makes them feel a little bit small there. So definitely a good way to do it. Now, let's talk about the mate tool, and one of the reasons I don't go into it. One, if you're under the...
Hey, Ryan.
Oh, I'm so sorry.
No,
Yes, Sean.
that's okay. I actually, so the streaming version of this started a little bit late, and there was someone who asked the question about what you showed regarding breadcrumbs. Was there an option that you advocated to turn on?
No, the only option that we talked about is if you go into it, it's whether you want it stuck in the upper right-hand corner, or whether when you pick on something, you can actually show it right next to your mouse. But in lieu of that, you can actually hit the D key, and that will just pop it regardless of where it's at. It's going to always pop it right next to your mouse there.
Awesome.
So it really is a user preference at that point, what works best.
Thank you.
And then something keyboard commands. All right. Going back to that mate tool, thank you, Sean. Going back to the mate tool here, it's, you know, like standard mates, they kind of work the same way we just showed you. Why would I go into a command where I got to start it up, I got to hit OK, I got to manage it? When you get to advanced mates, though, this is one of the places where it can be, you know, more apparent what I'm doing here. So, like, I'm going to go ahead and make these concentric to each other. And once I say OK to that, you know, here's why I don't go into this mate command. So I have to flip to a different place. I have to turn on the mate I want. I have to be very specific about how these faces are being selected. And I'm using the with mate here, which means I have to pick 2 faces from one part, 2 faces from another part. They have to go in the right place. Very order centric, very pick heavy. And then I can say OK. And then I can go back to my standard mates, and everything kind of works automatically again. 2 flat faces, 2 cylindrical faces. And it's just, I'm lazy. Like, if I can get rid of a mouse click, I'm going to do that. So I'm going to go ahead and hit escape and hit undo here. And basically, what I do like about not going into the mate command is I can pick the 2 faces that I want, or 4 faces I want to work with. And then when I let go of it, the default mate is the with mate. Didn't matter how I picked it, just the fact that I picked 4 faces. And now I can hit that enter key. The only thing I need to do here is do a right click to accept that. But you have all the capability of changing that too. It goes to center by default, but I could have said to rattle it around or change any bit of it all in that little window right there. But again, it was 6 mouse button clicks versus like the 9 or 10 if you go the other way. So, you know, why do I care about that? You'll see a little bit later why I might care about that. Yes, sir. Is there some hotkey that we're going to talk about? Are you sure? All right.
If that part was designed properly, where the origin is in the center,
yeah,
and you have a presumably top plane to work with,
mm-hmm.
symmetry makes better than the width mate if the symmetry mate has a plane to work from.
Mm-hmm. Sure. What is that?
Is the symmetry mate better than a width mate if you have a plane to work with?
I don't have actual data. I know the width mate takes up a little bit more resources on calculating than, say, a coincident or concentric. But when it comes to that symmetry mate, I'm not quite sure, because I can even set up things with the width mate that acts just like the symmetry. So where is that fine line? So I don't have good data on that. Well, yeah, from a user standpoint, yes, but again, I can use the width mate and do the same thing. So I can do it with a circle or whatever, right? And you're using a plane for a mate, so, you know, right there, we're gonna fist a cuff outside later anyway about that one. So, but yeah, I think it's when you get to those advanced mates, you know, button clicks, definitely, it's gonna be one button click versus the other, regardless. And I can do the same thing here, and the symmetry will pop up here as well too. But when it comes down to calculation time, which we'll get into a little bit later, that's where I think there might be a fine line for it. But, you know, when we're looking at hundredths of a second, I don't know if it's worth it at that point, right? All right, so again, mating on the fly, get used to that tool. It's really nice. Once you get used to it, you can kind of click and you just get into a nice little, you know, thing there. There's times where maybe my attention is outside, looking outside, and I just kind of clicking stuff on the screen. You know how the parts are going to react. You know that they're moving to the right spots. And again, the more you do it, the quicker you're going to get at it. No, not that one. Let's try this one. There we go. Mating on the fly. Copy mate components. Copying with mates. How many guys have touched that before? All right. Sometimes the copy with mates doesn't work. But one of the things that we have available here is the ability to copy items, like even all these items right here. I can actually copy these. And do you see the copy that I made? Yeah, it's way out in space somewhere. So if you want to know why or why I think why, ask me after the class. But yeah, threw it way out there in space. And so we can get in. But you'll notice all these are mated together. If you copy more than one item and there's mates between them, the mates between the items will also copy along with it. And it makes it nice and easy to be able to do something like this. It's basically acting as a sub-assembly. This can help with some advanced mates that maybe you can't do with copy mates. But it does work out pretty nicely there. And sometimes you're trying to do a pattern or you're trying to do something and just you get into certain situations that they just don't work. And again, I could just grab 4 or 5 pieces, mate it to each other, copy them, and then just remade up one of the other items and get it back into place there. So main thing here though is understand that select it from the screen with a window so you can see the items here or pick them manually. If I were to go through, hold down the control key, just like copying a regular component. Now, you'll notice it's only showing me one. And then the other thing that happens is when you let it go, sometimes you'll see it just off the screen. Sometimes it's like 5 miles away. So do a zoom to fit, find it out there. Don't go, oh, that didn't work, and then drag and drop it a couple more times. There's a lot of deletions that occur after that. Sound good? So just know that you have this ability when you're copying more than one component, and it could work nicely. Yes, sir. Yep. Yeah, in fact, I just ran across that the other day. I'm like, oh, I didn't know you could do that. So I may sit here and tout about how awesome I am. But honestly, when it comes down to it, it is nice to, I learn new things all the time. So if I grab those, drag them in, and we can see that all the parts came together there, and they are all mated. Now, I do have all the minus signs here, but a control Q should fix all that one day, because they're not moving. Oh, that's why. Never mind. The wrong part got fixed. First one in wins. Float. There we go. And that's mostly due to the fact that I keep on grabbing that Technic Cross. So yeah, good way to go from one assembly to another assembly. So awesome point. I will add that in and not give you any credit for it though, okay? All right, center profile mate. This is one that actually I've been trying to get into a little bit more. And honestly, we can use it for some nice stuff here. There we go. Mates. So if we take a look at this, it's worked better in my head, especially when I grab the right parts. Wow, there we go. All right, so taking a look at this, there's lots of different ways you could do it. We could use the planes, we can use a width mate, we can do all kinds of stuff. I am becoming very mate adverse in my assemblies, again, with a little explanation later. So I tend to go towards things that are going to reduce the number of mates, not just my mouse button clicks, but number of mates. So if I were to think about this, I could do coincident to coincident to get it centered. I might use a symmetric mate. I might use a width mate. I don't use a distance mate because I need it, I need it centered in there. But one of the tools that we have is the ability to just go ahead and not pick the standard mate, but pick what we call the center profile or profile center. And what that does is it makes it coincident and it centers it based on the geometry around it. You can rotate these, although you're not going to see much except for the rotation of the origin of one of the parts. And I can hit OK. What I like about it in the long run, that's one mate, right? Previously, I would have had to use 2 mates. Maybe I could have lined up the origins if they were done just right. But fact of the matter is, it's nice to be able to come in, pick 2 faces, and then just center that in. Now here, because we have a circular profile, we can actually grab that and spin that around. I'm not putting any holes on here though, so I don't care if it spins around. Even though in real life it would be welded solid and stuff like that. And again, we're going to get into why that's concerning later. The other thing that we can run into is I could use a smart mate, which allows me to pick a corner and then drag and drop that to somewhere else. The problem I have here is somebody in their infinite wisdom decided that a nice little fillet on the bottom here would be pretty. All right, again, we're going to talk about this later, but it's extra geometry and all that good stuff. Fact of the matter is I could use a smart mate here, which is me using the Alt key to pick a hard edge, drop it onto another hard edge, and you can see that it gives me a coincident and concentric. So this works really good for fasteners, especially if you have hard edges on those. We can put it in. But again, I tell people I'm mate adverse. What I found out is if I pick the bottom face, hold down Control, pick the circular edge there, I can do the center profile and say okay to it, and it will still spin in there, but it basically took the place of 2 separate mates at that time. All right. The other key benefit here, though, is I can do this and go in and copy if I need to, and then I can just go ahead and pick these other edges, whatever it may be. Also, I gotta say it. Okay, there we go. I'm missing like little steps here. That's crazy. All right, and so we could throw it there. And honestly, if you use the hole wizard for that, use the pattern tool. All right, it's going to be way better. Even though I can do that quickly, and it kind of gives you a little bit of a power trip to be able to put a lot of parts in quickly, use the right tool for the job. All right, it's always going to be better with patterns, mirrors, and stuff like that. So keep it in mind. Again, we've got these tools in the mate tool. You can go through them. You got to pick boxes. You got to pick things in a certain order. But at any point, I can come up here, right-click, and have all the information. Lock profile, rotation, flip the mate alignment, flip the dimension. All that stuff is here. Never even had to go down here and find it at all. So kind of keep it in mind. 1, it's making you quicker. 2, some of these mates are working nicer. Did your thing go out? Womp womp. Is it coming back on? What did you do, Sean?
I don't know. Press too many buttons. I'll go check. I guess in the meantime, there are some seats here, so we can migrate over.
Yeah.
Check with these guys.
All right. So the problem is 6 years ago is when I started doing this. Like nobody knew about some of these tools, and now a lot of you guys know about it. So apparently, I'm going to have to up my game here a little bit. Thanks. All right, large assemblies. I like Star Wars and I like Legos.
The projector in that one of the projectors
so
in room 3
I like to
just
hum the
like
song in my
stopped
head.
working. I'm wondering if
And
like, timed out or
this is one of the assemblies that I did here. So this is
I'm wondering if there's,
13,300 components
people around
put
here.
together. All parts, pieces and parts lovingly built, put together in assemblies,
Just, like, restart to
sub-assemblies,
kind of
and then thrown into
refigure it. Yeah,
Visualize
I'll ask him
and
that.
rendered out.
I'll
And,
see if,
and then somehow
that
you
might work
trick
for
your
him.
company and you get you these high-res posters that you can hang
It's
on your
not-
wall at your office.
it's actually
So
on
it worked
the
out pretty good.
less, like,
Um,
yeah, not as
now,
many people.
to
but
kind of
I'll ask
put
him if he
this
wants to do that.
here, put it in context here. Let me go ahead and open this assembly up and we'll let it go a little bit. But so this all started with the fact that I have people that would call up and they would say, hey, large assemblies in SolidWorks aren't the best thing in the world. I'm like, yep. And then we'd take the phone up and kind of move our merry way. Kind of agreed with them. And the real issue here is I didn't know everything that they had to do, and they couldn't give me all the answers I needed. So I decided that at one point that Millennium Falcon, when it first came out, was about $500, and I kind of looked at my wife, and she's like, "Yeah, don't even think about it." I'm like, "Fine, I'm going to make my own Legos." So I started making my own Legos in SolidWorks, and the benefit is I go, "Hey, I can learn how large assemblies work because I'm going to control this from the very part level all the way up to the top level." In this particular case, we're looking at about 26,600 components, and it is now fully loaded. No lightweight, no large assembly mode. Everything is there. I'm running high-end reflections. You can see the reflections in there. They're live and all that good stuff. I've got pretty decent detail. I am breaking down my graphics a little bit there. And if I open any of these components here, in fact, if I take a look and come in, you can see that the parts are fully loaded with all their features. So would you guys like to learn how to open tens of thousands of components in less than a minute?
Yes.
All right. So with the SOLIDWORKS people. All right. So conveniently, they're recording me today. So we're going to talk in ASL for the rest of this. All right. So, so this was really the output of it. Yeah, I got to play with toys and stuff like that, but it was nice to be able to get to a certain point, start running into issues, and then be able to go back, and I knew everything that was going on. I could make adjustments. I could try different things, see what the output was, and then kind of take it from there. Ultimately, I found some really surprising data. And we'll kind of get to that here in a second, but I did kind of want to put proof in the pudding that this stuff does work, and it works amazingly well. Andrew has been really cool to find people that are having assemblies, and then I get a cool call, and then I get to show them. And yeah, so, you know, these are things that I like to do. It's a challenge to me, figure out what's going on, show them what, you know, figure out how we can help them out and kind of go from there. And again, honestly, I do this because, well, you know, wait, I do this because I care for my customer and I like my job, but ultimately I like making pretty pictures. All right. So some of the things that you need to consider is mates. Subassemblies are definitely your friend, because when I bring a subassembly in, I don't really pay attention to the mates going into the subs. I only pay attention to those mates at whatever level I'm at. But there's some things that we can get into. My test for everything is a control Q. How many of you guys know what control Q does? All right, if you're in an assembly and you hit control Q, how many times do you go, oh, right? And that's kind of my test there is do I feel comfortable hitting a control Q? Now, I will tell you, and I conveniently close out the assembly so I can't prove it to you. I could hit control Q and it probably takes about half a second to rebuild the whole thing. All right, it does not take a long time. It doesn't take nearly as long as it should. So those are things that, you know, I try to keep in mind. Use those sub-assemblies, they're your friend. My control Q is kind of my litmus test to say, are things going bad in the background? Couple things though that, you know, I run into quite often though is, well, you know, God bless McMaster Carr, right? I like threads. All right. You know, there's things we can do. So one of my things is, for me, there's a lot of concerns in a large assembly, and there's a lot of things we can look at, but probably the two things that I hit most is going to be graphics is number one. Are you downloading these beautiful models that have threads on them and all this good stuff? And look, you can have the coolest video card in the world, and it's not going to help you. And if you just have bad data, if you have a lot of bad data, we have to calculate that mesh before we even hand it off to your video card. You know, so, you know, these are things that you always want to pay attention to is, do I have the right geometry? Am I doing the right thing? And so I always look at threads. I'm looking for balls in a ball bearing. Oh, the number of times I get a ball bearing and it's not just a donut that's solid. I get in there and all the balls are in there, and they got the cage on the balls in there, and then there's a cover covering all that. So why do I even care? And then you look really closely and it's a NSK dash, and it's like, really, why is this? You know, all this is geometry, and the more geometry you have, the longer it's going to take to open, the longer it rebuilds. We won't even talk about drawing. So if you're in my drawing thing earlier, we got ways to do that, but we have to calculate that. I don't care if I have a machine that's as large as this building and I have a 1-inch ball bearing in here. If that text is on that ball bearing, I have to calculate all that out, period. Right? So keep it in mind, dumb those things down as much as you can. And if you have to spend 5 minutes to dumb down a model, that 5 minutes, I'm going to tell you, is going to be well worth the 5 minutes. That will literally, in some cases, save you days, if not weeks of time think about all those rebuilds. Think about how many times you open up. Think about how many times you make drawings. So keep it in mind as you go through. Every single fill is going to be shown in there. I like text on my part. I had an oil company down in Texas come in, having massive rebuild times. It was taking forever to make drawings. And the biggest thing I did is they had these huge panels for gauges, and they were flame cutting the letters in so that mud and stuff would fall through and they could see it and read it all the time. The biggest thing I did was I suppressed all the letters as cuts. And then I went to the sketch for the cut and I did right click show. That sped it up so much. It was ridiculous. I mean, it was night and day. Creating drawings, it took less than a second to create the views. Before, it was taking 45 to 50 seconds just to make a view of one of these things. So it is a massive change. Is there trade-offs? Sure, there's trade-offs, right? Like, it's not physically cut in there and it looks kind of weird. Great. Blur your eyes up some more, pretend that everything's cool. Sometimes we have to give a little, right? Look, now, if I'm going to render it, if I'm going to send it to a machinist to actually do the flame cutting, stuff like that, I'll have maybe a separate configuration that has all the detail. But when I'm working on a massive assembly, I don't really care that it says fuel on a burnout plate that's 100 feet away from where I'm actually trying to work on stuff. Kind of make sense? All right. Lots of tools that you have out there. There's a lot of ways of downgrading geometry, whether it's imported in or you're suppressing items or whatever it may be. The other thing is top down. Top down is awesome, but there is a critical thing that you have to keep in mind is, do I want to keep my top down so that it's active and live, or do I use top down to do my designs, which severely decrease the amount of design time? But whenever you do something that really helps you get ahead quickly, there's usually a payment that you have to make back later. So, the last company I worked at, we said, hey, look, you can't release anything that has an external reference. And you'd have thought that I said, bring your puppies in so I could kick them in the head. And that's not what I was going for. And they were like, I got to use it. It helps me so much. I'm like, dude, I'm asking you to spend 10 minutes to go through your part, get rid of the external relationships, make it related to itself. That's all I'm asking, right? We're not doing design work anymore. You don't need those external references. And, and then they were like, well, now I feel like I'm doing double the work. Okay, top down helped you get so far ahead so quick that you're just paying back a little bit of that time that you saved, all right? It's always going to come down to that. So be aware, if you do have top down, you're going to keep it in. It is going to equal a slowdown. Your rebuilds will get longer. Part of it is because I may have to rebuild down into a subassembly. If I have a part in a subassembly that has external references and I do a rebuild, well, SOLIDWORKS is going to go, well, I need to check if that part's okay. So that means I need to rebuild the subassembly and I need to check that's okay. And those mates need to be double checked and checked out. And then it can go up to the top level. So everything that I'm saving with subassemblies up here, top down kind of just short circuits the whole thing. And we have to rebuild from the top down to the bottom and back up again. If you are doing top down, try to stay away from multiple references, right? Don't have part of it related to this part, another aspect of it related to this part, maybe a third part in the background. In fact, if you try to do that, by default, SOLIDWORKS has an option that says that if you try to reference yourself to another part other than the first one, it'll actually pop up and go, hey, we can't do this. And then it tells you the option to turn it off because, look, you might have to. I get it, right? But you kind of want to be a little judicious about what you're doing and how you're doing it. There's a little bit of thinking. And again, is it going to hesitate you for a couple seconds because you have to think about it just a little bit more? Yeah. Is it going to help you out in the long run? Yes, it is, right? Help you make good decisions. Your rebuilds can go bad, and this is due to solar activity half the time. And then use it when it's needed, right? And look, there's companies out there, even when I did custom machinery, we did it with top down. We actually left the top down in, but we were really careful about what we referenced to what. So we didn't have just these references spraying all over the place. It was very organized and it went to certain things and all that good stuff. And, I had customers and they'd call up and they're like, the conveyor's at the wrong height. It needs to be 35 inches. I'm like, all right, cool. So I change it. Of course, like 20 minutes later, they're like, it needs to be at 35 and a half. And I'm like, well, because we had it top down, wasn't really a big deal. I changed one number. I had hundreds, if not thousands of parts we're updating to account for it. I gave them a hard time and I charged them extra money for engineering, but they didn't know it was taking me 20 minutes to get it done and we're on my way. So And then there's some functionality that we have in, we call it future. I need to get rid of that. But you can get in and we could start kind of pulling information into a part, and it gets close to what like a Creo user would call like a skeleton function or a skeleton part. And I fought it for 30 years and I'm kind of looking at it now. So might be something on the horizon there. Lightweight components. Notice I opened that big assembly up and that was the first thing I said, it's not lightweight. Lightweight is great as long as everybody's playing by the rules, all right? Best example I have is we were using lightweight. It was taking 25 minutes to open our assemblies. We were using lightweight. If we turned lightweight off, it was an hour and 50 minutes to open our assemblies. But the problem is when we finally opened up the assemblies, we found out that we had 400 mate errors in all the assemblies and sub-assemblies and everything, which was actually exacerbating all these issues we had. So best thing that we did was we turned it off, and we actually got our open without lightweight to open in about 20 minutes. So we went from an hour and 40 minutes to actually less time than what it was before, and able to get it in there. Once everybody was following the rules, it worked out great. Biggest problem we ran into is someone would change a part, they'd open the sub-assembly and check it, and then they go to the next sub-level and they check it, but there was still 2 more subs levels before you got to the top level. They weren't checking those interims because it was gonna take too long. And it was causing us a lot of downtime and a lot of mate errors and all that good stuff. So we implemented it, said, hey, you got to work it all the way up and all the way down. There was people that complained about how much extra time that was going to be, but look, when you can take it and I can open something up in a third of the time or a quarter of the time, why would I not spend that time there? Speed packs are another way. A lot of people don't like speed packs. They can be used well in different situations. So if you're adverse to it, give me a call. Let's take a look at what you're doing. Maybe they might be a good fit. Probably not going to be a good fit. We don't know until we take a look at what you're trying to fit it into. Sound good? Good performance gains. That's what I will say. So published envelope is the new functionality. It's new as of 2020, so it's like quite old now. But that's something that I'm still playing around with that today. We're supposed to put quotes in if all else fails, change. There you go. Other considerations. So we talked about geometry, right? That's one of my big hitters. I can usually knock a lot of bad stuff out just by going and dumbing stuff down, making it easier to work. That you get that hex head bolt that's got that nice little chamfer around it on the side. Get rid of that, right? And honestly, when you get geometry like that, I mean, I can make a hex head bolt just about as quick as I can download a hex head bolt. So, most of the time I'll go to McMaster card, just look at the sizes, draw hex, extrude, draw circle, extrude, ta-da, hex head bolt, right? So keep it in mind, try to dumb that down, and, that's all I can say. The other aspect though, the number other thing that I look at is the number 2 thing I look at is mates. And, there's a couple different things here. I've got a couple methodologies up here, but really let's look at mating practices. And, one thing I want to ask you guys, if you're working on any kind of assembly, one thing that I'll pick on is I'll see fasteners in particular are fully defined, right? Concentric, coincident, there's like a parallel mate in there, get it from stopping, spinning around. Does that sound about right? How many guys fully constrain all the components in your assemblies today, including fasteners? All right. Really, Andrew? Oh, okay, good. We can attend it. No, that's good. That's good. So, all right. So, and other than Andrew, because I know him and I talk a lot about this. If you guys can't tell, why do you guys do that? I'm going to pick you 3 guys right there. Awesome. Good. Is that worth the time that you wait around? Yes. It is? Okay. All right. So say you wait around for 40 minutes a week because of this. And I can show you that something will take 3 seconds to figure out and get the same warm fuzzy. Would you be open to that? Possibly. Okay. And there was some more hand raising. Is that the same reasoning that you guys are thinking? Yeah, pretty much. Okay. Say that one more time.
Fully defined is important for us. We want to be confident that everything is mated completely.
Is that because you guys are sitting close to Andrew? Oh, okay. All right.
The way we've always done it.
All right. So, you know, a lot of times, so that is one aspect of it, and the definitely debates can be had about it. Another excuse that I hear quite frequently is if my part can't move, then SOLIDWORKS doesn't have to calculate as much. And it seems to make sense because if a part can move, well, it seems like SOLIDWORKS should have to calculate something in the background to understand what's going on. Well, it does, but the only time it does that is when you touch it and drag it. That's the only time that those mates are then going to start to try to calculate themselves out. In fact, taking that to a point, if you go to the SOLIDWORKS, you go to their something base, their knowledge base, you know, someone posted this question and it says, are assembly performance benefits, are there assembly benefits to having fully defined rather than undefined? And they really say in the first sentence, there's no assembly performance benefits whatsoever, right? So your guys' feeling of, hey, like it makes us feel better because we know it's fully constrained, still on board with that. But if you do fully constrain things because you think you're helping the computer out, 100% not doing that at all. In fact, they go on to say, you know, you actually may make it worse, your assembly performance. And so that's one of the things that comes into it. And what it really comes down to is one of the things that I was most surprised about is I found that the more mates I added on, it wasn't like when I went from 100 mates to 200 mates, it wasn't twice the performance hit. It was actually more. And then when I went from 100 to 1,000, it wasn't just 10 times worse, it was a lot more. And I'm like, wow. And you start charting stuff out, and then all of a sudden I'm seeing that familiar like whoop and going up, and I'm like, this is kind of exponential. And so I did a lot of testing, wrote a lot of numbers, hit a lot of rebuilds, hit a lot of stopwatches. And that was, I was like, wow, that's awesome. So I figured this out, and I high-fived myself and talked to my coworkers. And then I went to the knowledge base and I typed some stuff in, and sure enough, it was in the knowledge base as well too. In fact, I did this back in 2012, 2013, and come to find out, it was like 2008. SOLIDWORKS came out and said, hey, by the way, this is how this stuff works. And I'm like, oh, great. I did all this experimenting, and SOLIDWORKS had the answer the whole time. So I tend not to experiment now. But we can see here, the time to solve a mate has a squared rather than a linear relationship. So, when you have, really it comes down to the calculations. And the only thing that I can kind of figure is when SOLIDWORKS recalculates, when it captures those mates or sees those mates and it does the calculations, every mate is basically calculated against every other mate. And so the first one will go against all the other ones. It goes to the next one and it calculates itself to all the other ones. And I don't know if you guys have ever had to solve a matrix before, a matrice. If I have 10,000 mates, that's a 10,000 by 10,000 matrix that's being solved. Does that sound fun to anybody here? If you've done it before, right? Okay. So, this is one of those things where small changes in your mates can have dramatic effects the larger your assembly is. Look, if you're working with 10 pieces, 100 pieces, you're not going to see a big shift there with a couple of mates that maybe are making your fasteners not move or whatever it may be. But as you get more and more and more, 5 extra mates, I mean, when we're talking exponents at a high level, 5 extra mates is a huge shift in calculations. So just to make sure it's really big in your face. This one I told you about earlier, about 13,000 components. If you think about the number of calculations that has to go into it, 3 mates per component. So I'm doing fully defined stuff here because that's required. There's 39,000 squared. This alone has 1.5 billion calculations just to solve the mates in it. Does that sound dramatic? Yes, sir.
The caveat is mates at the same assembly level or sub-assemblies that are flexible. It's not touching the entirety of the model.
Right. Yeah. But when I am opening that, and if I've made any changes to any parts that at the lower level, it does have to build those all the way up.
It's not squared of all the mates in the entire assembly at every level.
True. Yes, that could be broken down into smaller levels. And this is one of my experiments of, can I show everything at the top level and control things? Can I break them down to the smaller pieces? So yeah, absolutely. If I brought 39,000 pieces together, first off, or 13,000 pieces together in assembly, first off, please call me. There's some tools we can use. One of them is called use subassemblies, right? We can get you in there. Now, one of the things that was said earlier was the lock rotation. How many of you guys use that? Okay, so lock rotation does act as a mate. It's not shown in the mate thing. It does show a different symbol now so we can know, but basically you're kind of making that concentric mate a 2 for mate. So it still has to capture both of that. And that's actually in that database as well too. So keep it in mind. You know, one of the things I try to bring across is, you know, I put thought into my assemblies today, things that I used to not do. I actually do a lot different today. And they were developed over time. And a lot of times, you know, look, I have a chance to play. And so I'm able to try a lot of different things and go, ooh, that was good. Ooh, that was bad. But I do try to, you know, stay rigid. Like, look, I can come in here and cheat the holy heck out of this whole thing and just be like, yeah, I rock. And then I move on and all that good stuff. I work out of a home office. So, you know, I'm like the office employee of the month all the time. So, you know, but I do try to keep within realm of stuff that I've developed. Like I do have, there's top-down stuff that's going on in there. There's, you know, flexible sub-assemblies that are in there as well too. So it's not like I try to get into a little high tower and go, oh yeah, this is the way the world works. I do try to bring stuff that, you know, I would do in the real world. And then I can hone that stuff on when you guys call up and say, hey, Ryan, can you take a look at my assembly? You know, I can take a look at it and I can see similarities to what I did. Or I could go, oh, wait a minute, I see this. Why are you doing this? And then we can have a conversation about it and maybe learn new techniques or different things that make things faster. So this was said by a wise person, Ryan. All right. And also, booyah. That's all I got. So in review, especially with those large assemblies, I really do look at graphics and I look at your mates and stuff like that to see if there's not anything we can change. But also keep in mind that there's other things that are going on in there. And there's new techniques that are out there all the time. Again, you know, I've talked with Creo users for a long time, talking about skeleton parts and skeleton features. And honestly, I'd say about literally 5 weeks ago, someone showed me something that made things really compelling. So I don't want to get into it right now. I want to play around with it. I want to see how it works. I want to see if it's viable. I want to use it against things that I'm aware of and know how to use. And, you know, who knows, maybe that might be something else I talk about in the future. But other than that, here's my email address, Ryan Cole at ryan.cole@goengineer.com. Feel free to get hold of me. I'm more than happy to help you guys out, whether you're my customer or not. I'm one of the people out there that really does like to help people out. Sound good? All right. Thanks, guys. Appreciate your time.
You still got 20 minutes, so we're going to do an open forum.
Oh, no. Okay.
Shouldn't have gone the full length. I'm sorry.
Well, usually I go over 10 minutes, so.
All right. We don't know what happened to the old Ryan, but. So I want to point out the sub-assemblies thing. We're really doing this, by the way. If you think I'm joking, I'm not. So for the sub-assembly side, I was at a customer and they had about 100 parts, 100 unique parts in a subassembly.
Okay.
Which means if you make a bill of material, I always try to define unique part versus total part count.
Right.
So if you make a bill of material, if you have 100 lines, those are 100 unique parts. They could be used 10 times, 100 times quantity or all. So about 100 unique parts of the bill of material that cannot achieve. And then they had about 500 parts in the assembly.
Almost.
Okay.
Yeah, so in order to get the assembly a little faster, I recommended breaking up into subassemblies. I keep whispering. For anybody in machine design, assemblers don't
He's still doing Q&A. You can.
So I do think there's a very practical industry thing of just make your subassemblies manageable. Right? My rule is it's a bomb and an isometric view of the assembly that probably need more subassemblies. Is my, but from a performance standpoint, Ryan, where is that arc of
So-
more subassemblies equals more faster versus more subassemblies having the additional file overhead slows things down?
Well, I mean, I have an assembly that has 2,400 components in it, but at the top level, there's 10 total mates. And there's probably 6 major subs in there, and each one of those may have anything from 10 to 12 subs in there, sprinkled with parts as well too. So it's not just 4 subs making another sub, making another sub. It's 4 subs and 40 different parts that are copied and and all kinds of stuff. I haven't really, I haven't really cut it that close on that. Like I kind of keep, I just what you said about subassembly use. That's kind of the way I think anyway. And I always think about the fact that I know that this cell is going to make these components, and they're going to pass those off in a basket to somebody else. Some other person's got 8 baskets with loose parts, and these subs over here, they're going to put it together. I always look at it from that level, and from that level, I might be losing time, but that's that whole thing of losing time in SolidWorks, but I'm running it the way that it's going to be manufactured. So at that case, I'm more concerned at keeping that manufacturing together, knowing that I'm not really causing too many issues with the whole how many subs do I have in there, and does that make sense moving forward. So again, it's not something that I haven't deep dived that particular scenario, but my gut says be reasonable with it.
But initially, it sounds counterintuitive. Add
Right.
more files, add more sub-assemblies, increase your performance.
Yeah.
And there's a threshold. So don't think that just shoving everything in a file.
Oh yeah, absolutely. I mean, if you have, yes, I see where you're going now. So with the subs and stuff like that, yeah, I'm sure there's a break point, but I mean, if you're dealing with, okay, so with your 500 and 100 number, yeah, you're kind of getting some weird territory there. And we talked about ratios earlier, so.
Yeah, I mean, my general rule is 35 unique parts-ish. 30, 35 is kind of what fits in a bomb, fits in an isometric, is what the assembly team likes. Again, custom automation equipment, product design would be different. And then that generally gives you about 100 mates if you're inserting each unique part once and using mirrors and patterns after that.
Yep.
Show of hands, everybody's familiar with the hide children in your SolidWorks assembly configuration bill of material display properties. Yes?
You say that again, that was a mouthful.
I'm sorry. The hide children option in the SolidWorks assembly configuration bill of material display options. Maybe Ryan can show us. So,
No.
So you download a PhD cylinder, SMC cylinder, Maddox, whatever. You've got the body and the rod, so it's a SolidWorks assembly. But you want that cylinder to show up as a part in your bill of material. You don't want to have purchasing by the rod and by them, right? So there is a hide option, show as default, and then there's a hide option, which transforms your assembly, your sub-assembly, into a part in the bill of material. So you get an SLD ASM on the hard drive, but you get a parts icon in the bill of material, and it won't indent down. But does anybody know what the show does? Or the show is default, does anyone know what the promote does? Sir?
I like to use that for energy chains. So I'll have an assembly that has a bunch of energy chain links on it. And that assembly will just be called energy chain for this sub-assembly or whatever. Just something dumb name that's a file. When you promote it, it'll take its bill of material.
great everyone coming back. So thank you so much for us here. As you can see on site, a bit longer. It's a great conversation. Thank you so much for participating in. Hope to see you at your info here in February once again at streamcreative.com. I want to keep all the best in the background. But yeah, thank you once again. I'll be live tomorrow. Check that out. Live design, Carlos TV. And yeah, hope to see you